Peter, I can't hear you. Peter, I think you're muted.
I'll try it without my headset for a moment. Maybe that works better.
Yes. Yeah, we can hear you. Perfect.
Okay, wonderful. Wonderful to have you on board, Malika. It's fantastic. Really extraordinary things that you've been doing with Microsoft, with AI, financial services. It probably makes sense for us to go pretty much straight in because you have a really, really interesting presentation to go through.
Yeah.
How do you feel? Do you feel comfortable doing that?
Oh no, most definitely. I think I've been completely glued in the screen since morning. With the amount of with the richness of the conversations we've had around AI, and I think a great job Objectivity has done in really plugging the right people, and specifically it was absolutely amazing. So I'm quite excited, and I think, as you rightly said, let's get straight with the presentation because I have quite a chunk to cover.
Exactly. I'll jump into the background and then I'll join you in a moment again towards the end of your presentation. Wonderful.
Perfect. I am just 1 second. I'm trying to share my
I can see it. Your screen looks great. I can definitely see it.
but you can see the small titles at the end, right?
That's true. So you can press the
Yep.
if you want the full screen, you can.
Yeah, so I'll do the full screen.
Okay.
Perfect.
Wonderful. Okay.
Great. So I think I'll start my conversation by saying that I think we are all in this era of world where we be faced with daunting challenges and unprecedented needs, and what we all do today is fairly more important now than ever. And today I'm going to talk about what's next, the technology trends that will shape the future of AI in financial services. But before I begin, just a bit of a background of who I am. I work at Microsoft as a data and AI cloud solution architect, which means I work with customers in financial services, specifically in UK, to successfully and responsibly leverage Azure, which is our Microsoft cloud service, to accelerate the digital transformation journey for our customers. So basically, it's all things data, from the very scratch of data platform through to AI. Now, this includes designing optimal architectures on Azure that delivers valued outcomes and orchestrating an ecosystem for really inspiring customer experiences. And outside my job, I work very closely with advisory bodies like the All Party Parliamentary Group of AI in the UK, and think tanks like the Atal Innovation Mission in India, to really explore the impact and implication of AI in financial services. I'm an alum of the London School of Economics, where I finished my master's in data science, worked as a data scientist in the industry, and then now at Microsoft as a cloud solution architect. And if you have any questions or you want to reach out to me after the session, I've put my LinkedIn handle here. So bouncing off ideas on AI, I'm absolutely for it. And before I talk about the future of AI and the conversations we've had in the morning, I think what I want to do right now is to do a little bit of level settling and really define what do you mean by AI. Now, AI has a long history, and the definition has changed every few years. But fundamentally, AI refers to computers understanding the world, reasoning from a large set of imperfect data, as well as interacting with humans in a much more natural way. So, firstly, understanding AI enables us to understand and interpret data of our environment and our world at scale. With reasoning, machines do this by taking large amount of imperfect data, adding logics on top of that, so that we can understand and make decisions based on that data. And it continues to learn over time as we keep feeding more data, and finally interacting with humans and lowering the barriers between a human and machine. The goal is to allow machines to communicate with humans in a much more natural way. And what AI currently is just not a technical definition, but it's also a set of business and social definition and thought processes where we take large quantity of information and use it to train decision making algorithms to produce results that we go and use in a different way. Now, the interest and possibilities in AI is accelerating specifically because of three key forces that has happened just in the last 1 decade. The first is the influx of large amount of data, and this is continuously increasing every day. And guess what? AI needs data. The second is huge amount of computational power, specifically with the burst of cloud technology. And thirdly, and most importantly, algorithms which has allowed ideas that has been around for quite some time now to improve the accuracy to the point where they become a great practical value. And with these technological advances, AI has become more and more accessible for everyone. As we'll all agree that AI has a very significant role to play in transforming the financial sector, however, the adoption of these technologies within the business is still very primitive. Now, whether that's automating a mundane administrative tasks or really improving the overall efficiency and productivity, once the adoption increases, enterprise will transform dramatically. Now, I'm pulling a report by the MMC venture called the State of AI Divergence, which talks about the AI adoption in 2019-2020. And the key aspect of that report was that AI adoption has tripled in the first 12 months. One in every seven large company has adopted AI, and in 24 months, two-thirds of large companies will have live AI initiatives. Furthermore, the landscape benefits from a growing supply of open source AI APIs, frameworks, standards, and norms that enables quicker and better AI adoption. Well, all figures and trends show one thing: adoption is on a clear rise. However, the adoption varies as per the industry, and in financial services specifically, we've seen few challenges. And I've taken a snapshot of a survey conducted by PwC, which highlights the key challenges in the AI adoption in financial services, specifically in UK. And this includes two key barriers here: skill gap and trust. Let's take a dip deeper. Now, when we talk about harnessing the potential of AI in future, we need to talk about what is successfully, but most importantly, responsibly. We definitely need to be cognizant of the implications of these systems and the vast benefit that comes along with this application. To do so, here are my top three considerations. The first is democratizing AI. How can we make AI accessible for everyone and every organization, regardless of the skill level? So you could be a high school student running your first line of code or working in a giant enterprise. The focus here is to make AI accessible for everyone and every organization. The second consideration is innovating yet responsibly. How can organizations take an ethical approach that AI has a positive impact, not just economically, but also socially? And finally, upskilling, developing skills for tomorrow. And this is all about how organizations can talk about equipping employees to understand and use AI to augment their roles, but also think about the younger generations. How can we prepare them for future? And this will not only happen based on the technical skills. As we talk about the potential applications of AI across different pillars and industries today, we need to explore the broader societal concerns which these advances bring along, and most importantly, building public trust in AI. For AI to achieve its full potential, and we'll all agree with this, it must be a platform. And this platform will need to be powered and delivered at a truly unprecedented scale and democratized so everyone can innovate and build on top of it. The future of AI will be in the hand of developers who can harness its powers, and you won't need to be a data scientist or a machine learning specialist to do so. As we think about the future of technology, it really resides in the notion of intelligence. And at Microsoft, we have an approach that seeks to democratize AI with our low code, no code integrations in Azure machine learning. But the key objective is to take this implementation from an ivory tower and make it accessible for every organization and everyone. With our bold ambition to democratize AI for all, which includes harnessing artificial intelligence to fundamentally changing how we interact with computing, the agents in our lives, infusing every application that we interact with on any device at any point in time with intelligence, making these same intelligent capabilities that are infused in our own apps at Microsoft, the cognitive capabilities available to every application developer in the world. And while AI provides a significant benefit, it's also critical to understand and manage its risks. Decisions made by financial organizations regarding loans, interest rates, and insurance coverages are some of the most important decisions that can be made about a person's life. And for AI to play a role in these decisions, it's essential that organizations use technology responsibly and plan for an unintended consequence. This is important for both ensuring compliance as its legislation evolves and maintaining trust within your customer. AI deployment in financial services is increasingly impacted by the lack of customer trust in transparency, accountability, fairness of these solutions. We at Microsoft are committed to the advancements of AI and machine learning, driven by the principles that put people first and tools to enable this in practice. At Microsoft, we have six core principles to build AI ethics, which must align with human ethics, and this must evolve over time. Some of the key questions we should be asking today is, how is AI designed and used responsibly? How do we establish the ethical principles in practice? And how do we govern its use? In order to implement responsible AI principles into practice and building trust through machine learning lifecycle, we at Microsoft have leveraged the state-of-art technology which enables responsible machine learning development, deployment, and use. And this falls across the three pillars. The pillar one is understanding your model and build for fairness. Now, this includes explaining model behavior and uncovering features that has the most impact on the predictions. Using built-in explainers in Azure Machine Learning for both glass box and black box modules during model training and inferencing. And the most importantly, the what-if analysis to improve the model accuracy. The second stance is protecting data privacy and confidentiality. So building models that preserves privacy using the latest innovation in differential privacy, which ingests a precise level of statistical noise in the data to limit the disclosure of sensitive information. Eventually, identifying data leaks and intelligently limit repetitive queries to manage the exposure risk. And finally, controlling and governing through every step of machine learning process. So accessing built-in capabilities to automatically track the lineage and creating audit trails throughout the machine learning lifecycle. Obtaining a full visibility into the ML process by tracking datasets, modules, experiments, code, and more. With our key focus to enable responsible AI development, deployment, and use in action. And lastly, and the most important, How do we prepare our today's workforce and future generation for these opportunities and skills to comprehend these technologies? As AI capability continues to evolve and expand in future, technical literacy will be key to navigate the digital landscape, adapt and collaborate with AI. Technology advancements, the rise of cloud, the socio-economic and demographic changes are shifting the expectations and placing new demands on society. While these changes hold a great promise, education systems will need to respond to prepare students for practice. While students will still need to study the skills of collaboration, communication, critical thinking, creativity, and computational thinking, it becomes increasingly important to equip students with technology skills that needs to thrive in this digital economy we live in. Skills like cloud computing, AI, machine learning, productivity, and much more are already in demand in organizations around the world. Yet jobs remain unfilled, and the talent gap persists and is set to widen. To empower students to be future ready, the focus area are three, and I'm going to quickly walk you through them. The first is sparking curiosity with STEM, computer science, and giving a purpose to learning. The second is extending productivity skills and grow competence in emergence technology concepts I spoke around, which was AI and machine learning as our key focus today. A LinkedIn Learning recent review shared that the two hard skill employers are looking for is cloud computing and AI. The cloud skill talent is set to be the largest and most impactful of all talent shortages we've encountered, and it's only going to go grow. At Microsoft, we have a large number of programs designed to support and cultivate students' interest in technology and support employability, including a renewed focus on role-based learning paths and associated certificates, self-paced learning path, and more opportunities. What I'm most excited about is Microsoft Learn, which is a platform by Microsoft which offers a diverse resource to help students, educators, and IT skills up in a self-paced, self-directed online environment at absolutely no cost. My final thoughts today is the notion here is to make AI available to everyone. We must democratize AI and the access to these tools so that anyone can use them. Much of the onus to do that is on us, the platform builders. But all of us today share this responsibility as well. So, whether you're building a mobile app or creating a new tool for precision agriculture, the benefit that flows from a scaled AI will need to reach as many people as possible. The barriers to entry in AI must be lowered. And secondly, and the most importantly, is we must take care to develop this new platform thoughtfully, accountably, and most importantly, ethically. We all committed to a set of responsible AI principles that are very core to all our AI developments at Microsoft. But all of us in the technology ecosystem need to be vigilant that AI products and applications we create are inclusive, equitable, and human centered. Thank you.
That's an amazing presentation. Thank you, Malika. Really wonderful. And I've been thinking about sort of way that you guys are taking things forward over at Microsoft. I'll add a couple of people into the stream if you don't mind. I have Matt here next to me right now, who's been looking at some questions coming in, and Henry is going to be talking about testing in the area very shortly. Ian has also been looking at some of the questions coming in, and Ian has a lot of thoughts to come along with here. One thing that really strikes me, Malika, about what you guys are doing at Microsoft is the way that you're pulling together the BI part of what you're doing with the Power Apps, with everything else in such a way that you end up building using the components you have today, this ecosystem is now coming together, including the low-code stuff, on top of the Azure sort of cloud infrastructure. And these things, sort of 1 + 1 = 3, and then 3 + 3 = 29. You know, you're doing quite some interesting things. How is the financial services industry responding to this changed offering? Because it's quite a change, it's quite a revolution. I mean, that you're undertaking. How are people responding to this in finance, in your experience?
Absolutely, Peter. I think one of the key things I would like to highlight, and as we work with our wonderful customers in financial services, is the skill gap. There is a major skill gap of finding the right set of data scientists and data engineers. There are different personas of data and AI. I can possibly sketch a lot of roles within the whole stream of data and AI, starting from the data engineer to a BI analyst, right? One of the key constraints we've seen with customers is how do we pull the right talent in place? And that is the biggest barrier. So at Microsoft, under Satya's leadership, our bold statement is to democratize AI for everyone. So we want to make sure that we provide the tools and kits that we at Microsoft use to everyone, whether it's with the cognitive services, whether it is the Q&A deployment we've done, or bot frameworks, which really is a low code, no code options that help customers accelerate the journey of innovation. And that's where our key focus is. Another thing to keep in mind is in financial services, this industry is highly regulated. So for anything to be implemented in course has to have the level of ethics and security in place. Is your customer data secure? Is the platform you're building is insecure? Where is my data going? All of these questions are not just the questions of financial services, but the customers of financial services. So our key focus with Azure machine learning specifically is how can we orchestrate an ecosystem that can give our customer an opportunity to build these machine learning models, at the same time build that ecosystem of ethics, security, and privacy much in line with our applications.
It's actually interesting how with cloud platforms, because of their inherent insecurity, you actually end up building a security into them in a lot better way. For example, you have to have encryption, you have to have all of this stuff. If you would just build a local app on your local server, you typically leave, the passwords on the table on a post-it or something like that. But because you're directly building into cloud infrastructure, that just doesn't fly. And it's the same effect that we've been doing with our cloud platform also, is that we've noticed that actually we've kind of accidentally ended up with a hyper-secure platform because of the fact that you cannot leave the passwords on a post-it.
That'll be horror.
Yeah. So, and what is your password, Henry?
Hunter 2.
So, Ian, you've been looking at these things as well.
Yeah. I think it's really coming back to the point Malika was making regarding democratization of AI. We've actually seen, a huge support by Microsoft of the current COVID situation with promotion and enabling the team, certainly the education environment. You mentioned the Learn platform being available and free of charge. Is Microsoft going to push and promote that as well as they have done the Teams infrastructure?
Sorry, I didn't get the question well. There was a slight crack. I'm so sorry. If you can just repeat the last part.
Just saying that Microsoft has done a really good job with the COVID situation in enabling the Teams infrastructure.
Yes.
You mentioned that the Learn platform and the skill shortages. Are Microsoft going to promote the Learn platform more widely than just within the industry at the moment?
No, most definitely. I think so I can talk where my work is more around. Inside Microsoft, I work very closely with this campaign we have called DigiGirls, and where we work with young girls from the age of 12 to 17, and how can we teach and make AI look cool to them? Okay, so the intention is to make AI cool, and Microsoft has invested heavily in these learning platforms around Microsoft Learn, and it doesn't just limit us to the industry, but also outside the industry to education specifically, and in with our collaboration with partners which really orchestrating and building enterprise-ready solutions at in the industry. It's just not limited to industry; it's limited to everyone and anyone who wishes to learn about AI and machine learning.
Thank you.
I think one of the things for us, Malika, is where someone would describe a data scientist to me as kind of nearly 50% data processor, nearly 50% subject matter expert, and perhaps the remaining 1% doing the fun stuff, the modeling. How do you bring it all together as part of this huge initiative that you have?
Most definitely. So I would completely agree with it because I've spent my time prior to Microsoft being a data scientist, and 50 is a very easy number. I've spent 70% of my time doing the dirty data engineering work, which is not fun. But I think with Microsoft, our key focus is to really orchestrate the whole process from ingesting your data to storing the data, to preparing the data, and finally using this data for visualization or your BI or building reports or all the fun stuff you can do with AI, all coming together with these. And another offering we have is called the Azure Synapse Analytics. And Azure Synapse Analytics is basically building both the worlds of big data and data warehouse coming together. So you have different personas within a project where you have data engineering doing the cleaning, and that goes to once the data is up for ready, it goes to the data scientist to build their predictive models, and eventually you have a BI analyst who will use that information to visualize. And what we've done with Azure Synapse Analytics is bringing all of those worlds together and providing a platform. So you have the start of your project from ingesting the data to eventually visualizing this data all on one platform.
It's really cool. I just added Hans to the talk here. Hans, welcome.
Hi, thank you. Nice meeting you.
It's you're doing some really cool things as well. Malika, that was a really terrific talk, and I think, Malika, that you will be wanting to sync up with Hans, because a lot of stuff that environments that Hans is deploying in are ultimately also Azure environments. So these things really, they really do link up. These things, they really do, in a beautiful way. And so, okay, Hans, do you have any questions to Malika? We're only 3 minutes away.
I just jumped in literally 2 minutes before, so that would be a bit of out of context, so to say. So,
all right, no worries. Okay, cool.
I think the one big thing, Peter, for all of this is that the transparency is increased and lifted, and the lid is taken off the box, so that when things go right, business owners can be sure and have the confidence that things are in fact going right. And when things go a little wrong, if we're in finance, someone doesn't quite get the loan approved that they wanted, there's a real clear description so that they can rectify that issue and perhaps try again.
Yeah, kind of
that's
like
I think.
Making AI explainable and democratized is really one of the goals that we want to do here. It's kind of lift open the box, even if the explanations in there wouldn't be like super simple, but make the explanations available and make the data available to look into. And I think that's one of the like key developments that's been happening lately, that it's not 100% black box anymore. You can dig in.
Well, Einstein said, as simple as possible, but not simpler. And so if we oversimplify, then it's a black box because it's oversimplified. So that's just the way it is. In that case, Hans, we're going to leave the floor to you. Malika, beautiful speech, loved it. And we're going to have a panel at the end of this after Katie as well. So I'd love it if you could join that. And Malika, if you can, we'll have Q&A sessions after Hans and so forth as well. So if you have time, then please do stick around and join the Q&A together with Hans as well. It's going to be good fun. So let's see if we can find Hans. If you wouldn't mind sharing your screen, please, then we'll add that to this, and I shall be rude and remove myself and everyone else from this thing for the time being. So let's see, Hans. There we are. I can see your thing now. There we are.
See my screen?
Absolutely. And there we are. So everything is beautifully ready to roll. And I think the best thing for me to do is to disappear and let you just enjoy.
Thanks. Yeah. First of all, great pleasure to be here with you at this Objectivity AI conference. And my name is Hans de Visser. I'm responsible for product management at Mendix. Mendix is one of the players in the low-code field. And what I would like to highlight today is where we are seeing application development going. And the title that I gave to this presentation is Making Smart Apps Smartly, because AI really works as a double-edged sword, if you like, in the realm of application development. And let me illustrate it with an example. This is a greenhouse in my home country, the Netherlands. We're pretty big in exporting agricultural goods, as you may know, tomatoes, paprikas, and so on. And if you've ever flown into Schiphol Airport coming from the southern part of the country, you see big plots being lit at night. And you may wonder, like, why have people these big lamps at home? These are actually greenhouses where they are giving doses of light to a crop, which makes them grow even at nighttime. So that's all about driving productivity, so to say, of greenhouses. Now, why I'm bringing up this story is that there is a manufacturing company that is a customer of ours, who is actually building those green light systems. They are manufacturing them, or selling them, and so on. And they were almost about to be unseated by competitors from low-cost countries. So they figured, like, what do we do to retain our customers and to provide actually something that is going to leave us or get us sustainable competitive differentiation? And they started to think about the idea of doing, for example, predictive maintenance of those lighting systems that they were putting in greenhouses, powered by artificial intelligence, so that they could really see on the basis of usage patterns, like when is this system potentially going down, and can we do predictive and proactive maintenance and service for the greenhouse owner, so that the greenhouse owner actually is never out of light for a particular segment in the greenhouse. And when they started to do that, they also discovered another thing, like there are sensors that you can put into the greenhouses, like how much daylight or sunlight does a crop get at daytime, and relate that to scientific data that they have around what is the optimum growth curve for a particular crop. You should know that there is a point in time, even in the night, where it doesn't make sense to put another doses of light to that crop anymore, because of the fact that it has reached this optimum curve, and that optimum curve is different from crop to crop. And they started to combine the data from the lighting systems, the sensor data of how much daylight such a crop could get, and build a completely new platform around this, which they started to call the Grow Light platform. And their proposition has completely changed from being a classical manufacturer of green light systems to actually consulting and advising greenhouse owners about how to optimize the ROI of their greenhouse. And it has led them to become a market leader in that space again. Why I'm bringing this up? We are seeing that even if growing crop gets digitized, it's fair to say that we now live in a software-driven world. And the way how we are doing business has fundamentally changed, and so must application development. This whole Grow Light system was built in a very iterative fashion. It uses the combination of a low-code platform that I represent, coming from Mendix. But we are also using services from Azure, from Microsoft. So the smartness basically comes from AI services that we leverage there, including the data lakes that are being created to feed sensor data into the data lake that can then be mined. The pattern that we are seeing is that applications more and more become smart. What I mean with that is they become context aware. So they know what a particular person is doing at a particular time, and is optimized for giving an experience to users in the context. Applications more and more become intelligent, so they are fed and powered by all sorts of AI services. It could be NLP services, it could be cognitive services, it could be machine learning services. And it's very easy these days to weave such services into your application experience. And then as a last constituent, so to say, we see that applications become more proactive. So rather than the classical pattern of a user going to an app and checking, like, is there something that I need to do? Applications or the applications come to the user and it manifests in many forms. It could be a chatbot interface, it could be a classical UI interface, it could be notifications, or even voice services to trigger someone to do something. And the type of platforms that I'm talking about here is typically called in the market low-code platforms. And there's a few reasons why these platforms are skyrocketing. First of all, productivity across the developer spectrum. I'm using some definitions from Gartner here, just for you on the webinar that are not super familiar with low-code. I would like to call that out. So it's all about rapid application development, and not just the development, but actually automating all of the steps in the life cycle, one-step deployment, execution and management, using declarative and high-level programming through abstractions. And here there's a pointer for what I will tell you later about how we are using those abstractions in the context of building smart applications, but also building applications more smartly, using AI techniques to power developers. And the whole notion of low code is based on being or working with so-called model-driven development patterns and doing meta-database programming languages. So you create abstractions for ordinary people to build fairly sophisticated applications without them ever being trained as traditional Java or .NET developers. There's another thing that is a key characteristic of those low-code platforms. All of the non-functionals are basically coming out of the box. So anything around performance, scalability, high availability, disaster recovery, security, and so on, is basically something that the vendor does for you. That doesn't say, of course, that it's not something that you completely ignore. So when you run apps in operations, you should, of course, look at how well my applications are behaving, and depending on how you have developed or architected your solution and used particular patterns for visually defining the application, your application may do better or worse, so to say, looking at those non-functionals. And that's, again, an area that we see a big opportunity for to further increase the productivity of developers and also take hassle out of the application development lifecycle. Couple of characteristics. So low code, and that's not just the company I represent, but low code in general. Microsoft has a low code platform as well. There's a couple of other competitors on the market, but generally you see a couple of patterns. So you can leverage a bigger part of your workforce for software development. So software development is not exclusively anymore for experienced Java or .NET developers. So we democratize application development to an extent. You get a lot of architecture out of the box. So all of the kind of scalability aspects, as I just mentioned, are basically covered for you. They're very focused on being able to create very engaging experiences across a number of devices and modalities, and then deploy at any scale at your cloud of choice. The whole promise of low code is that you should minimize rework to the maximum extent. So if an idea starts small, starts to be successful or become successful, and then should scale out, you should be able to do that without any major rework. From a developer spectrum point of view, we're covering really the range all the way from citizen developers who have day jobs in the business to professional developers and a couple of roles in between, with an idea that you should have targeted IDEs for no code and low code. So that's basically the segue into how we are dealing with AI also in our platform. So where's the challenge? I just mentioned on the previous slide that if you can build applications 10 times faster, you could potentially also create a mess 10 times faster. This is straight from a conversation I had with a CIO of a utility grid operator a while ago. He was about to go for a low-code platform, And his fear was like, okay, if I unleash development to a larger pool of resources who can then go off on a tangent potentially, am I not painting myself into a corner with an unmanageable and unmaintainable plethora of applications that are creating me a bigger headache than I have today? Now, there's a couple of things that we do anyhow in these platforms, which are more traditional, like consistency checks. Low-code platforms in general perform 20 to 30 times more consistency checks on common patterns than traditional coding platforms. So that's, a bonus. There's ways to do, for example, static analysis of models against an ISO 25010 standard. That's a standard for maintainability of applications. So you could do that at some time in your project. You can obviously do application testing, and also in the low-code space, there's a low-code approach to test automation for functional validation. The big question, though, is what can we do to add virtual team members that would be helping developers real-time to build great software? And that's where AI kicks in. So rather than do it in retrospective, which to an extent happens with the points I mentioned above, we want to make sure that whenever someone is developing, we are giving super specific and highly reliable recommendations on what to do to build great software. This is not something that comes out of the blue. There's this prediction from Gartner that around 2022, at least 40% of new application development projects will have a virtual AI co-developer on their team. And this is basically a pattern that we observe. I will share you some statistics around how that basically works for Mendix developers already today. Why is there such a good fit for low-code platforms and AI? And I'm now zooming into how you can build applications more smartly. First of all, find common patterns and then turn them into standard, ready-to-use visual widgets, toolkits, building blocks, and modules. That's basically the gist of low-code. So all of the kind of coding patterns that you typically find in traditional frameworks are abstracted, are packaged in such a way that they can be used almost as building blocks. And by putting developers to an extent a bit in a straight jacket, you will build up an incredible amount of patterns that are highly valuable for evaluation and for mining if you put them in the cloud repository, which is something that we have done over the course of the last 15 years. AI enables next generation low-code platforms to automate further and more complex and contextualized tasks across the software development lifecycle. And we can do that faster and also more consistently and with higher quality. And that's a kind of idea that we got, and we started to execute upon it. We've launched this a good year ago. It's called Mendix Assist, and it's actually the first AI augmented development capability in the low-code space. In the meanwhile, some of our competitors have also launched similar services, but we were first to market with this. Now, let me tell you something about how we have done this. As I said, we have a big cloud repository of models that have been created over the last 15 years across many, many industries, across many, many geographies, and for different developer profiles. And to give you a perspective, there is around 6 million of those models that we have in a cloud repository that we have ran through TensorFlow, the AI proposition or open source project from Google after they've bought TensorFlow from this UK company. And we have started to mine those models on an anonymized basis for applicability in application development. Some of the key characteristics, the way how we are developing, and you will see that in a minute, our business logic is through visual diagrams. And in this service, it's basically context aware. So it knows exactly when you are enabling the service, like this person is building a microflow for this particular domain model or data set. And I can make recommendations as to what to do with the data set, looking at the activities that he or she has already created or that were already there. It's context aware, as I said. We support left and right patterns in most cases, and that's a logical start. you would see like you would get a recommendation for something that you put at the end of a visual diagram. The context is then known, so the more context you have, the more precise you can make recommendations as to what's the next best step. What we are doing is also looking to the left side. So if you would insert an activity in an existing flow, it will look left and right, and it will determine the context and then give very specific recommendations as to what you could do as a developer. And as a last point, we provide with auto parameterization options. So it's not just making a recommendation like add an activity, for example, of this type, or create a decision box that should evaluate a rule. We can go as far as filling in the parameters already for you, so that again you are more productive in avoiding a lot of keying in of data. Some facts: we have achieved 95% accuracy right now of top 5 suggestions. So we always make sure that we give more suggestions. So there's a ranking in priority that shows at the pop-up screen. So you can choose as a developer what you're actually taking for a recommendation. The number of permutations that we are checking actively is 88 million. We have trained models with 88 million of those microflow patterns for machine learning training. These are derived from the 6 million different models that we have. And we support it in 2 of the IDEs that are part of our platform. So this works both for citizen developers as well as for pro developers. Let me give you a glimpse of how this works. On the next slide, you see an animated GIF here. What you see is that this blue box or blue dot that you saw at the beginning is making a suggestion for next activity to add. You see that here again, add a validation, and it knows the context of what the flow is about, and it presents you basically the options of what you could do there. Again, another activity is being added that should lead to a decision. So add another element, merge with a decision, and off you go. This also gives a lot of power for developers to not just look at all sorts of controls that you can find on the right-hand side of your screen if you would be looking on the full canvas of a Mendix development IDE. It just also saves a lot of dragging and dropping for those developers. And just to give you a feel for the adoption rate that we've currently seen, 60% of the developers in our community are using this service already, and 40% of the microflows built with Mendix are based on using Mendix Assist. So we are already ahead of the curve, so to say, looking at this Gartner prediction that 40% of users would be using it. It's actually 60% in the developer community already. And 40% of all of the content for microflows is built using this AI-assisted service. Now, there's obviously room for improvement. So this is, for us, really the very start of it. A next thing that we are working on is performance optimization. You could build a very elegant and powerful solutions in a platform like we offer. But still, you could make stupid decisions as to, for example, put a commit in a loop. And in order to avoid that, we're going to do 2 things. First of all, add a static analyzer to the IDE, so that if we are seeing that you're using patterns that are not wise for performance, we will warn you. It will give you insight. We will give, like you've seen on the previous slide, contextualized recommendations, and then doing automatic refactoring. Now, that is more traditional, if you like. Static analysis is not per se powered by AI technologies. It's just making sure that you have a set of patterns that you can check against, and then off you go. And what we're going to do to make it smart is combining it with a runtime profiler that actually looks at your application in the runtime and detects if there's performance anomalies and relates that back to coding patterns or modeling patterns that you may have applied that are not optimal for performance. And these 2 elements combined will yield a very powerful service for yet another aspect of application development, namely optimizing it for performance. So that's basically the direction that we are going, and step by step we are gonna automate elements of the software development lifecycle and make life for developers easy. That brings me to my last slide. So your future development team will probably look like this. Apart from a few human beings doing the job, you will have a pair programmer, as you've just seen in action on this animated GIF. You will have a QA pilot, for example, the one that is checking for for performance proactively. We are working on services for processing user feedback, like, for example, automated tagging of feedback that you get so that you can classify it more properly and see which recommendations from end users using your application are coming, and if there's particular patterns there for easier requirements management. And then last but not least, an ops genius that is doing automated monitoring of applications running. And it may go as far as, for example, stopping a service and resurrecting it if they're seeing patterns that are not, per what the rest of the market does, or so, or what the rest of the applications are doing, based upon models that we have trained for that specific purpose. That's basically a glimpse of how we see the future of app development. I would like to thank you for attendance and open it up for Q&A for the last 5 to 10 minutes.
So absolutely amazing presentation, Hans. And I have so many questions. Do you mind if I just add a couple of guys into this that
sure. Yeah.
wanting to be involved in this as well?
Of course.
Matt has been thinking about these things really hard. And Henry is next to talk, and he's going to be talking about various testing systems that are totally applicable to this as well. Very, very interesting. Ian has been looking at this actively, and I'm about to add Edgar as well. Edgar from San Francisco. Edgar, are you joining us from Menlo Park, or are you joining us from home?
I'm joining you from Menlo Park home.
Okay, wonderful. Edgar is head of augmented reality, virtual reality at Facebook.
Nice.
Okay. Over to you, Hans. So Hans, there's several things that really struck me about this, and one of them is, so you're talking about increasing the speed of development by 10x, and from what I've seen and from what I've heard from people like Matt and Ian who have used the Mendix platform, that's what happens. And then there's a whole bunch of stuff that you don't think about. And in a way, is it the case then that when you move into that world, you need to implement some new good red tape, and you automatically bypass a whole bunch of redundant red tape? So to me, red tape has always been something that can be very positive. Correctly applied red tape can really help.
Absolutely, yeah. I think the gist of it is that in low-code platforms, that's one of the reasons why they are so successful. First of all, we are bringing indeed a 10x level productivity for ordinary people to build very sophisticated applications. The guardrails that we provide are helping or are preventing people to go off on a tangent. Functionally, applications are always correct. You cannot, or technically, applications are always correct. You cannot deploy technically non-functioning applications in a platform like ours, and we're not unique in that sense. So most of the local platforms do apply these patterns. The opportunity we see is to further increase the productivity by adding real, virtual team members and drive productivity with very active recommendation real time. So rather than do it at the end of your day or at the end or midway the project, you're actually constantly being helped with people that are, virtual team members that are experts in a particular domain based on the models that we have trained, and you get the common wisdom of a whole community and millions of artifacts that we are mining for that particular purpose.
Wow. I've got a question for you around that as well. Is very much, I guess, tied into best practice, and kind of many developers, different organizations will have their own styles and formats.
Yeah.
When you look at AI assisting, how do you determine what's a good or a bad model How do you teach your AI to make those recommendations it does?
Yeah, that's a very good one. So when it comes to the models, the models in Mendix are based on a so-called metadata repository. So the metadata repository is built in such a way that multiple of the DSLs that we have, for example, for the domain model, for the user interface model, and for the application logic and the security model, are aware of each other. So we can detect patterns, like if you are building, for example, a page and are linking it to a domain model, which is maybe not optimized for performance, for example, and also observe that in the runtime, then we can give you a recommendation to make a different pattern. So it's not just codified knowledge, but also knowledge that we derive from how we see applications behaving in the cloud. Plus, just mining the repository with machine learning techniques, and we're using TensorFlow specifically for that, to make sure that people get the right recommendation for if we are detecting that someone is building a flow that is similar to what someone else has built, or a group of people have built before, and make the right sequence of activities.
Cool. So Henry's about to begin his talk, but just before that, Edgar, what's your impression of what you've heard? Do you think Hans is making sense, or how do you feel?
So I'm sorry because I joined late, so I cannot comment.
I had the same. No worries. with the previous speaker. So
no problem at all. No problem at all. Cool.
Yeah. Okay.
Matt, you had one question that you were.
Well, I just think one point to make. So, with the up to 10x sort of speed improvement, of course, that's important without compromising quality.
Yeah.
But I think for lots of people, Hans, that we work with, two of the key benefits. One is that the documentation is always in line with the process.
100%.
So the process may be wrong, but the documentation matches it exactly, and that's a big benefit.
Correct.
And I think the second piece is to have, which is so strange to see, but to have a business person slide their chair along and sit by a technical person and both understand the same process, so you can have that business knowledge and expertise all the way through the development cycle, is game changing.
Correct. Yeah. I'm glad you bring it up. That's one of the essence or essential things that we do, aligning business and IT together, and are really joining the two at the hip, so to say, for better outcomes on the development side.
It's huge.
Nice.
Nice. One question which I don't expect you to really answer. I noticed you said regarding the kind of virtual assistant impairment. One thing we find with our traditional developers is often they work well with certain colleagues and not other colleagues. Do you think the paired programming virtual assistant will ever acquire personality?
Yeah, we are of course discussing that. Like, how intrusive should this person be? We have made it, not a real character so far, but I could imagine that we would go as far. Maybe it's a character that you can kind of configure yourself. That would be completely ideal for developers. Like, I'm aligned with this type of person who is basically either a bit more friendly or a bit more direct. We've kept it very neutral so far.
I can just imagine, if you pick any sort of national stereotype, you can just imagine sort of the
one character we didn't want to mimic is Clippy. That is what we wanted to avoid. But I think we did pretty well with that.
Thank you.
Wow, that's wonderful.
Okay.
All right.
I have to step out, Peter, so thank you for having me, and looking forward to see you on the next occasion.
Hans, that was absolutely really wonderful. And you're welcome to join in with the other Q&As if you have time, Hans. I know that you're running to a thing. I know you're doing that.
Yeah, okay. Take care.
All right. Thank you.
Bye.
And in that case, let's see if we can get... you wouldn't mind sharing it. Whoa, here we go. I'm adding your Cantinel thing here. And in that case, what I will do is I will remove everyone else from this, Henry, and the floor is yours.
Okay. It was a really interesting talk about low-code platforms and how raising the abstraction on the coding side really progresses the development speed and everything else in there. And the approach that we are doing is actually pretty much the same of raising the abstraction level. So what I'm going to talk to you today is kind of like quality intelligence and how we are raising the abstraction level from the testing side and from the validation side of things. Who am I? I'm Henry from Kentinel. I'm a pretty big science buff, sci-fi geek also. So it was interesting. The first talk that started the whole thing, there's one quote that I actually put into my talk. So it was a kind of funny thing. I've dabbled in a lot of different things, computational systems biology, skydiving, software, ML, and even AI. But if I'd have to say where I've spent my 10,000 hours in is probably in systems architecture and software architecture and developing that. But what I'm currently interested in is in making us all better magicians right now. And that's the kind of theme that we've been talking today. We've been talking with different terms, maybe like coders or creators, but basically creating stuff out of thin air with just bits. That's pretty much magic. What AI lets us do is offload a lot of computing and thought out of our own heads in the process of computers, and thus letting us focus on what's important and shifting through a lot of data and a lot of stuff that you don't need to understand. For example, looking at the history of computing, and even before that, previously you had to understand pointers, memory management, all of that. But what we've been constantly doing for the last 20 years, I think, we've been slowly raising the abstraction level of what we want to do. And that progression is still going on. And now with AI and ML and all of these other kind of non-discrete ways of doing development and connecting us into the platforms and interfacing in there, lets us do things that were not possible before, and lets us actually raise that abstraction level so that maybe at some point the dream of my personal favorite programming language would come through, where I could just sit in a conference room, explain to an AI system what I want, and that would be live generated at the same time as that was happening. So I wouldn't really have to spend time on the actual nitty-gritty coding, but actually creating the system and creating the stuff that at least yet humans are still the best at, on creating the new value and creating the business value in there and how to create that. And I think AI will help us interface with systems and data in a way not yet envisioned. And this is the kind of any technology is sufficiently advanced in this from magic that was the beginning of this whole AI Summit Day. And I think we are still pretty much on point with all the discussion that we've been going through, from healthcare to all the other side of it. And we've reached this point that the question is how to make this magic usable and understandable for all people, and how can we raise that barrier to make it democratized. And wow, that's the difficult question, and how to actually make this magic happen. How can we make AI know how to use our systems actually support us in trawling through the data? And I think that's why I've been kind of dropped into this testing and validation theme. Is that's basically how can we make software understand what you want to do with software. Basically, if we want to automate testing and we want to automate all of the test generation, all of that, we have to somehow explain to the AI systems how we actually want to use that software. What's the core purpose of all those lines of code so that we can actually test it. And that's why the problems in validating software and testing it are, I think, the ones that will enable us to create systems which understand the softwares, or any software that you give it, understand how to use it, and kind of go and help us interface with that piece in a lot more different ways. And also one interesting thought was that what we were discussing previously in the initial topics was that how we have problems with people coming into grips with AI or AI technologies because the data that they give is sometimes counterintuitive to our experiences. What we want to do is also, because of the way that we want to make AI more usable, we want to design it in such a way that it actually drives that absorption and not rejection, in the kind of the way that we were discussing about the viral infection, that our immune system doesn't strike it down, but actually absorbs that as a new advantage that we want. And building these kind of systems, I think, is the low-code approach that we've been discussing with a couple of firms here, and the really great examples of democratizing coding and making the abstraction level even higher. And I think this is a good example of the text is really small, but I think you can get the idea that if I want to access programmatically currently one bit of this website, I really have to dive into the dev tools, dig it out. It seems to be something like H3, story listen item, headline, and some hash behind that. Now I would have to tie this into my automation code if I would go through the code route. And this isn't really a sustainable way of doing it. There's so many different programming languages, so many different environments to test end-to-end applications. Tying that kind of testing and automation into the actual code lines in itself is super difficult when doing it that way. And that's why we've also done a lot of work using AI and using machine vision algorithms to really raise the bar of abstraction in there and raising it into a level that's human intuitive. What we kind of want to do is this. This is the kind of our way of writing test cases where you abstract away the code. You only have the kind of flows. This could be any kind of person or human tester could follow this kind of thought line that, hey, we are in some kind of state on the application. We click on a text called accept. We click on a text called change location. We click on a text called global, and then we should encounter a text called automate software testing with candle pace. And at no point in this script, we're actually saying that, are we testing this application on Android? Are we testing this application on the web client? Or are we testing this on a desktop? Or is this even some old Delphi system or something that doesn't really have good APIs to interface into? And this is the kind of abstraction layering that we can do using AI. You don't have to know the nitty-gritty details of the actual implementation of the software if we can access it the same way it's meant for humans to access it, and making robust test scripts based on that in the same kind of nice, good abstraction level where you can only focus on actually testing the functionality without diving too deep into it. And this is the kind of thing that we can now put people who are not experts at coding to do the actual testing and validation. So we can do business experts or domain experts to do the testing. We've even had nurses do some of the test cases because the way this is explainable in actual human actions in there. And what this gives us, let's see if this works. I haven't tested this before. Can I actually show you a bit of a clip from here on how we can actually, it's just the same script, test systems in Android without actually touching on the actual code that we're running, because this is all based on machine vision on the UI. And this is the kind of abstraction level that we are aiming for, so that everybody can verify and validate testing. And on the same level, we collect a lot of information based on the actual software, collect that, and we can then teach our own models to be even better in recognizing UIs. There actually isn't a big corpus of software or UI images from different software. That's something that there's a lot of like text, there's a lot of video, there's a lot of photos and all of that stuff, but there really isn't that major corpus about images from the UI. And what we're actually doing is an open source project called Open UI Dataset. We're collecting a lot of screenshots from different UIs to actually democratize also the way that you can construct those applications that use computer applications the way that humans do. And we'd like people to, of course, contribute to that and share some of those screenshots to make the data available to train all of these systems without them just staying proprietary data sets. And the kind of thing that all of this data collection leads to, that's what's the kind of our core thing, is that we are not a testing company, we are a software quality company. What we want to do is make sure that you guys who are using our platform make the best code available or make the best processes on making that software. And that's why what we've been now building on top of just the like AI powered testing and test scripts, we're doing something else with that data. We've constructed a model of how people integrate with software, or how the process of software creation works nowadays. Of course, that's deeply in DevOps. And you have a lot of these questions that have been becoming a problem. For example, is the release candidate okay for production? This has gone from asking this question once a year to asking this question daily. Is the release candidate okay for production? This decision still typically lies with the humans doing the actual releases. And that causes a lot of decision fatigue if you don't have any supporting data for that. Another thing is, what should I fix to prevent service outages? You might have some clues on what you want to fix there, but you do not have any kind of priorities, or what would be the biggest impact to fix immediately, which I could use to get the most quality out of our system. And other one really key component is, how can I improve customer satisfaction when I have something deployed? What are the kind of linking factors in there? And how can I improve the productivity of our team after this cycle? So how can I run faster through this cycle without everybody going burned out or the quality of the code worsening? And that's why what we've been doing is we've been modeling the whole DevOps cycle. And what we call this system is quality intelligence for DevOps. There's a lot of different nodes here of the actual software quality. So we'll be kind of going to the metadata layer, as we previously heard. You have to go in the metadata layer to actually create the models of what's actually going on there, and collect from a lot of best of breed applications, a lot of data, a lot of event-based data into a graph database to build a kind of model that's actually curated by humans. This is the problem that we were early discussing about correlation and causation. So this is the expected causations of the different parts of these nodes that we are looking into. And under each of these, this is actually, if you look into these nodes that we have, for example, integration success or code commits, they're not metrics in themselves, but under that code commit node, there's a whole tree of metrics that we can dive into. And the whole core concept of our idea on how to make all of that data available through AI and through machine learning is the fact that nowadays we have a lot of data, a shitload of data actually. Looking at the model that we previously had, there's hundreds of different connectors to that model that people can use to get data from the software engine. You do not have time to go dig through all of that data when you're doing a software release decision. What you can do is integrate one of them into the system, for example, the response time of our servers, and you get some kind of data from your system that actually outlines all of that data. You could go into the logs and dig this out. But what you want to do is actually specify certain breakpoints on that data, a kind of a mapping function that indexes that data between 0 and 100. And what you do is create an acceptable level of what you want to do. For example, 85. This is the kind of generic model that you typically feed into these kind of systems, that you have some breakpoint on that indexed data. When it happens, the node actually turns red. What we've even done on top of this is, because we've started collecting data from different companies, what we can do is infer some of these typical best of breed levels for different response times and all of that, but still apply your company's historical data on that to actually create some expected limits for this data. So what happens in the model is that when there's a lot of nodes, for example, CPU usage and response, these are combined, or the indexes, which have been mapped from 0 to 100 with the mapping function, they actually combine into a technical quality with a combinatorial function and with critical security bugs and everything to actually create the release quality node. And what happens here is that there's a lot of different applications underneath these nodes collected into one, and where the changes then propagate into the top node to say that, hey, you have actually problems with your release quality. And then at that point, you can see that, hey, I have a red light on my model. I think we have to do something with release quality. Let's dive in. This kind of abstraction layering, that first you have something that you can act upon. Release quality is on the red. Then you can dive in and look into what's the actual problem and actually prioritize what you want to fix first, improve the quality of your software. And the idea is that we have these data come from a lot of different places and abstracted into one, where you have one place where you can see what's actually going on and actually dive into different parts of the software processes. It's getting more difficult and more difficult with this way that we are doing continuous integration and DevOps and everything. You have a lot of data in there. So digging out the outliers from there is something that we can easily outsource to AI. And that actually works quite well. Looking at this is just like a correlation graph of some of the data that we have in here. You can see these deep red crosses in the data that signify that some of these data points that we are collecting are highly correlated. But then there's also this is actually an interesting data set, that there's some data that is kind of, if you look at on the right side of the legend, there's +1 and -1. And then on the 0, it says that there isn't really any correlation with the whole data at all, with one cross on the bottom. And that's actually something interesting from one client, that it's actually data about the usability and user end-to-end tests of Microsoft phones that they still have on the whole pipeline. So actually, this was something that they were kind of saying that, hey, we kind of knew that it doesn't really matter about the user experience of Windows phones for our development, but this kind of also proved to us that this model work that you can actually identify that Windows phones don't matter anymore. So that was also an interesting finding that can be found when you collate all this data into a simple form. There's actually a scientific paper back from my PhD days explaining how the normalization and all that is done, which you can look into if you're interested in the technical side of things and what we are actually running on. We are not running on Microsoft services, but we could run on Microsoft Azure or something like that, but we are actually running on Amazon. And with their Lambda functions, we've done a lot of stuff with just the XGBoost and the deep AI that they are giving is quite interesting technology that we've been using to build on top of this. And I think this is also the thing that we are not using just one technology like neural nets and that's it. We are using that, of course, on the machine vision side and all that. But this is typical kind of like typical regression modeling and all of that we also use on top of this whole normalized data set that we have of software engineering to actually produce predictions of your software quality, even before you release the software version that you're developing. We can actually, based on all of that historical event data that we have from different sources, predict the comparative quality of the next release compared to all the different ones that you have, and even point out which are the main predictors for that product quality, and point to you which things you really want to fix first if you want to get the best quality out of this. And I think this approach that you give AI the supportive task of kind of filtering out all the data and interfacing with these systems is really the strongest thing that we can do, and really empowers the humans and the developers in a deep way that you offload the menial tasks of digging through data to some other external processor. You roll out the prioritization of complex tasks to some other system. And then kind of the difficult thing is how you accept this fact that, okay, these AI systems can produce a lot of good discussion, good data for me. And how can I trust that system? And I think that's one of the most difficult integration things that we are, of course, struggling with also. And how can I trust these models? And how can I kind of really trust that this is the best thing to do? But it's kind of coming into the same thing that what we were previously discussing about digital assistants with personas. I think it's the same thing. Do you trust a friend that you're also working with, as AI is more and more becoming the supportive friend at your workplace, which generates this data for you and supports you in your tasks that you do. We've baked in a lot of AI into these like simple keywords that look really simple, like read text, but behind the whole lot of AI is in there. But as an end user, you don't really see the AI. It's really the same thing with programming, that you just see the simple user face. All of that other stuff is abstracted away, and the layer that is given to you is meant to boost your productivity and meant to give you the best tools to do what humans do best. So create the new features and create the new stuff that you want to do, and then prioritize on top of that. And this progression has been going on from the 90s, from the first processors. I think nobody nowadays would like to want to program with punch cards. We kind of evolved a lot from that with the different programming languages. And I think this low-code approach and the testing approach is something that's really pushing into play in. And kind of taking the human out of the QA loop from the simple tasks and only pointing to you the outliers that, hey, have you noticed that something's going on? Maybe you should check out what's going on in here, and kind of empowering you with AI as a developer. And then this is the kind of thing that I think is very good to also end on a sci-fi quote that let's us think the unthinkable, let us do the undoable, let us prepare to grapple with the ineffable itself and see if we may not F it after all. So thinking it of just as magic and something difficult will at some point become really part of your normal day-to-day experience, even though before it looked like magic. Airplanes, whatever, they've all integrated pretty well into our now complex society. And using all of that and using our technology, I think, is the next step that we are going to do on how we are developing software and how we are validating software and how we do testing to any kind of platform that you want. Thank you. I think I'm pretty much in time, and now I'm waiting for Peter to show up from the rafters.
So I think the trick for me now is to just remain quiet in the background and just wait for you hanging. That was a wonderful presentation, and there's a whole bunch of questions that have turned up. Ian, maybe you can represent Antonio if Antonio is not coming in. Let me please add Edgar to the talk, and if I may add Ian as well, and Matt into the talk as well. I thought that was a terrific talk. Just before we go into the first question, no, not before any first questions. Ian, can I just play the ball over to you, please? You have a whole bunch of things on your mind.
I think some has been answered in the chat window, but just to emphasize, Antonio raised a question that, do I need to train a model specifically to my app so I can use high-level testing language, or does it already come with that model and it's able to test any app out of the box?
You do not need to train any models on your app, and you can use it out of the box. And what we're actually doing is we actually have, if you want to go and test out the whole platform that we've done, pace.kenkel.com, we just released the free trial version that you can go and test out. There's, I think, 60 minutes of execution time available for free for anyone who wants to try how that actually works on the keyword-based testing. It's based on an open source technology called Robot Framework. Then we are part of that consortium and keeping that technology alive on the user side testing. So no need to train your own models. What we are actually doing then on the kind of QI for DevOps side is that it's kind of like a transfer learning. We have one base model that we are developing in the background, and then on top of that, we take your history and do transfer learning on that data to actually teach the model what you're doing. And that same data is actually used in our AI-powered editor, which actually can also, I don't have a demo of that, that's something that's quite new and just came out with a new release that can look into your testing mass. For example, if we have previous tests, Selenium tests or something like that, you can read through all of that data and then kind of work in the same way as a suggestive editor based on your data and not just a generic, what's the word? Static analysis data.
It's very much platform and also app agnostic then.
Yeah. And that's the kind of idea that with the same technology, you can test really old Java applications or you can test new web applications because the interfacing is done the same way as humans do the interfacing through the actual clicking and inputting text into text boxes.
Excellent, thank you.
Nice. Matt, you've been looking at this thing as well for a while. What are your thoughts?
I think how does it fit into your standard workflow? So it seems like a great tool. And also, do we still need some level of kind of exploratory testing? So you can script things like a human would, but sometimes you want to go rogue.
Yeah. Well, actually, the random testing or like exploratory testing is something that we've been looking into, and there's this tool called TestStar, which does this kind of monkey testing type of testing, but we've been talking. It's an open source thing developed in the Open University, and we've kind of interfaced with that so that we can actually use that to create random tests and exploratory testing. But of course, again, I think one important thing is that this is a supporting system for humans, and humans is still, I think, one of the best ways to do really good exploratory testing. Random testing and exploratory testing, I think, differ in the way they do. The random testing does stuff that humans won't do, and humans doing exploratory testing do stuff that totally random might not encounter immediately, or it's inefficient to go through all the different permutations on the UI.
And is it geared up in any way to address non-functional requirements, or is that something different?
Sorry, I couldn't. There's a bit of an echo here.
Non-functional requirements.
Yeah, that's something that we've been then doing on the QI for DevOps side, that we've been looking at the runtime and all of the other acceptable response times and all of that we can take into account on that side and point to your, for example, PO that something's going wrong here. And that's kind of different kind of data acquisition that we are doing on that side. But these two worlds, I think, are combining more and more. We kind of started with the stuff that came from the PhD and came from the university research, the data collection, and now been combining more of this typical way of doing testing and the data collection approaches that we've been doing.
So I love the way that you guys are predicting future software quality. I think that's a really cool thing. Another thing that I love about that thing is, again, that as we've heard elsewhere, that this connection between I don't know what that business people term means and that technical term means. I mean, it's such an overlap these days that whatever. But to the extent that there is a communications gap, we have to bridge it. And if it's possible to construct a few indices where you can agree that these are indices, where these indices relate to your business, and you agree that if this index goes up, that's a good thing, and if this index goes down, it's a bad thing. And you agree on the indices, and then you can monitor those indices at a high level. And that, to me, is nice. And above all, when it's nice to have a numerical basis for a discussion about whether or not the quality is going up or down, because I mean, we've all been in companies where everyone says everything is great, but you look at it and you say, no, it's not great. Or vice versa. Everyone is all pessimistic, and you go, that actually, hold on, this is actually pretty good. So there's,
Yeah, and of course, then what happens with the whole software quality is it's typically always an evolving target, a moving target, and that's why we do not really care about, setting that our quality has to be 80 or something like that. What's important is the delta, that you're actually moving towards better quality or moving away from bad quality in that system, and the delta is much more interesting in that the actual values, because it's an index. The index in itself
relative to yourself.
Yeah.
Yes, relative to yourself. Am I improving? And with all due respect, if Matt improves, good on him. But I have to improve myself. Edgar, how did you feel about that? Do you have any questions about that?
I like the part where we are defined as magicians, so I identified with that. But I don't know what else.
Cool. I have one philosophical question, Edgar. You've been at Facebook for a while now, and I have a question there. So this slogan, "Move fast and break things," and I've been thinking things. Okay. Sort of, you've done some innovations work at Texas Instruments and God knows where. You and I have known each other a long, long time, and in each of these companies where you've worked, you have been able to make innovation happen. That's something that's, sorry, I hate to sort of, I don't. You're a friend of mine. I should not build up your ego, but okay, I've done it now. So in this slogan, "Move fast and break things," that word "things," do you see that as being things being processes, or being hierarchies, or being egos, or stepping on people's toes, or how do you read that word "things" in the statement "Move fast and break things"? Is it just a purely technical thing, or what's your perception of that? Is it a broader thing?
No, originally I think it was like speed is of essence. And if you don't, if you fear too much, you don't progress, or you don't experiment. Interestingly, that slogan has been changed, and you caught me off guard, so I don't remember the new slogan, but it something like. And don't based on the infrastructure, so that I think that has
moved on.
That's moved on, yeah. But the idea, and I remember that, is like, what would you do if you weren't afraid, right? We have those like employee-generated posters that then become slogans, and I think that's the spirit of it. So it's not, especially nowadays where you need to think about what you're doing and the consequences, especially with such responsibilities for billions of people. So it's that's not a slogan anymore.
I understand that.
Yeah, and I think that's a good example about the organization also evolving. That previously you had the option of breaking things and moving fast, and now you're moving fast with stable infrastructure.
That's right. You're right. Shame on me. That's the right. That's exactly how it was changed.
Cool. All right. So Edgar, we tried out your presentation the other day, so we should start. And I should start finding your screen. If you could do a share screen, Edgar, that would be wonderful. And I can also see, by the way, that
out of the way.
Wonderful. And after you, just so you know, we'll have Eddie. So I'll just introduce you to Eddie real fast. Eddie, hi Eddie. So Eddie will be talking directly after you. Edgar.
Hi Peter.
So, hi there. Just introducing you to Edgar here for 2 seconds.
Hi, Edgar.
So Edgar is about to start. So, but just wanted to say hello. Eddie's a boss of everything AI over at Telefonica Group. So, and Edgar has a long background in telecom. So, cool. All right. So we'll back out and let's see if we can get your screen running. That would be wonderful.
I'm on full screen, so I cannot see anything else but my full screen. I hope all is okay.
I think you'll need to go back to your browser and do another share because it's not sharing yet, if you don't mind. So if you hit the escape button, please, just for a moment, and try to get back to your browser.
I did.
Let's see if we can do that. Has it been nice to you?
It says share. I thought I'm sharing.
Okay, let's see. Bang, 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 bang. Can't see you sharing a screen yet.
I can go in the application window.
Got it. It's there now. It's there now. It's there now. Got it. So now, if you can go full screen now, if you prefer that would work really well now if you want to.
All right.
It's perfect. It's beautiful. Okay, I'm going to disappear and leave the floor to you.
Thank you. So what I thought I would do is provide a glimpse of what we are doing in virtual and augmented reality, and then after that, focus on the role played by AI in our efforts in both virtual and augmented reality. I'll start with a slide that was shown 3 years ago now by Mark Zuckerberg in a public venue called F8, which is our developer conference, showing our 10-year roadmap. And you can see here the ecosystems and products we enable, and his vision there is like 10 years from now, there is technologies, a group of technologies that are very key to the type of products and platforms and products we will have 10 years from now. And 10 years from now was 10 years from 2018. So the three main families are connectivity technologies to essentially bring internet to and communications to the next billions of users. AI, which is pervasive in all our products, and virtual and augmented reality, which is viewed as the next communication and computing communication platform, which, as we will see, also use a lot of artificial intelligence. So let's start with VR. So VR is known by people to bring new immersive games or new immersive applications. It's difficult to demonstrate VR for those of you who haven't tried it yet, especially on a 2D screen. But I think it's more than games. So here is an example of two people co-watching a game, and that's an ad we run on TV.
Look at that. Oh! You notice everything down here. Yeah, these seats are ridiculous. I feel like I could probably be in the NBA. What? Look, if I had a solid month and a half, I think that I could be a real NBA player. Maybe I come off the bench. You should do it.
So that was like Adam Levine and a famous singer in the US and an actor, and you could see them wear this VR helmets and being virtually in a place where they were not. They were comfortably in their home, and they were transported virtually into a game, and you could see their avatars talking to each other. So it's all about like how you capture a place and people and therefore transport people in a new immersive world. We call it defying distance. So first, for example, here is a room. We can scan it, and then once this is done and captured digitally, you can put virtual objects, you can change backgrounds, and you can place also avatars, and there you go, or you can place yourself in a place where you are not, and you are immersed in a virtual world. The other important thing there is how do you capture places. So this is a video that shows on the left a real room, and on the right the room reconstructed, and you can see even the reflections on the mirror are well captured. But there are some artifacts, as you can see, some things here in the lamp. The edges are not correctly reproduced. But once you have places, then you need to represent people. So every year we have a conference called Oculus Connect. And this is our CTO, the Facebook CTO, Shrep. And Oculus Connect 1, he appeared like this. And that was his avatar. Connect 2, there was some progress, as you can see. And 2 years ago, he appeared like this. But it's still quite cartoonish, but big progress. So how do we do better?
Good morrow to you, my boy. It's healthier to cook without sugar. Thank you, she said, dusting herself off. George is paranoid about a future gas shortage. Approach your interview with statuesque composure.
So
I'd rather not buy these shoes than be overcharged.
So that one here is a colleague of mine. This is his real, this is him talking, and this is his avatar talking. And it's kind of unbelievable that it's so well done. You know, the hair, the teeth, the eyes. These were all challenges that we overcame, and I'll explain how. And when you get that, then you can have two people wearing even if they wear a helmet to be completely immersed, their avatars can appear not wearing the mask, and you will see how the boy sees the girl talking without the mask, and the girl sees the boy talking without the mask, all in real time. So here is what that brings.
What do you do for exercise?
I do yoga, and then I do boxing too.
What kind of yoga? Wait, okay, yoga and boxing.
Yeah, there's a nice contrast there.
Okay.
Yeah.
And then we also look at how to capture movements of body movements and the shirts even. So here is the body movement. That's just with one camera, a camera phone, and you can see that actually what we've done is we look at the skeleton of the body, how the muscles are moving when the person moves, and that's how this model is very accurate. Now this has been done. What you see here is like 3 years old. we've improved this even further. And here is an example of, again, a virtual human, and then you can see how the shirt with a Facebook Reality Labs logo is moving. So that was for VR. For AR, there are several types of augmented realities. There is audio augmented reality. It's your reality with an assistant that tells you things, like in the movie Her, for example. There is 2D AR, where, for example, in the car you have a heads-up display and some additional information is projected in front of you, or the same can be said with phones or with smart glasses. And then you have the helmets that we saw before, but with either video see-through or optical see-through, and then the ultimate AR eyewear that doesn't exist yet, frankly, where it's all-day wearable glasses that are stylish. You don't see that they are special glasses, and your field of view is virtual objects or new information is added to the reality you see. So you see, it's very different. AR and VR are very different, even though some technologies are common. With one, you believe you are in another reality, or you are immersed somewhere else, or you move and talk to someone who is far away. In AR, you augment the reality you see with information, contextual information most of the time. And while industrial AR is kind of easy to do, because you can have helmets, style doesn't matter, weight doesn't matter, even power consumption doesn't matter as long as it lasts for 1 hour or 2. For consumer AR glasses, that's a totally different ballgame, because it needs to be stylish, and the weight needs to be very low, and they need to wait to work all the time, and they need to incorporate RX, the correction because that's what glasses are for. Whereas in the industrial case, you can have inserts, or you can wear your helmet on top of your normal glasses. So another quote from Mark Zuckerberg, in 2017, and he announced that we are making the camera the first augmented reality platform. And this is what we do with a software called Spark AR that runs on phones and runs also on our Portal product line, for example. And it mostly enables people to add the AR effects, like this one. That uses some AI, by the way. And all these ones here. So this is fun for young and older people, but mostly young people. Here is other effect. Here's another effect when someone just opened their eyes or their mouth. A lot of developers are doing that. So that's all fun, but there is also Instagram shopping that is enabled by such technology. You can virtually try glasses, for example. You can try furniture before you buy, and you can try cosmetics as well, and see how it looks. So we have like partners like Essilor, Luxottica, Sephora, and so many others. In the UK, we've also brought some art pieces to life, thanks to that technology. And here are a few examples. And then now I'll spend some time on the glasses. I talked about what could be the use cases for such glasses. Well, they could bring you superpowers. For example, on the left, it can tell me I need to run 2 miles to lose the weight I gained from this ice cream. It can tell me why this baby is crying, maybe because he has a temperature. And if I'm in a bar here and I want to focus on one person and mute background noise selectively, I can do that. It's this audio superpower, visual superpower. It can help me see in the dark. It can share a scenery with a friend, or it can help me focus electronically better. It can also in a business meeting help me with some information that is superimposed. It can help me understand signs in a foreign language. And something that many people react to is this, which is like, okay, what's her name again? Oh, Laura Bragg. Okay, that's an interesting way to add information. Of course, this poses a serious privacy issues. So this is just illustrative. It poses also other issues. For example, if I'm in a crowd, there are many people I don't know, and if all their names appear like that, it's just not unusable. By the way, side note, this is a pre-COVID-19 crowd, obviously. Now what you would like to do is just focus on one person, and that's more usable then. How is this done? Certainly a lot of AI. Will this be done? Maybe not, because of privacy, for example. So now we go to the core of the topic, which is, hey, how is AI related to AR VR? Well, for AR, as you can see, a lot of the use cases are what I call contextual AI. So some of the use cases are enhanced memory and cognition. That's the examples I gave before. That makes use of extensive use of computer vision, intelligent context, natural language processing, and in this case, intelligence audio. For the realistic avatars, this is produced by that person going into a place where there are thousands of cameras filming him and capturing the audio, and the idea with AI is to reduce the compute time and the number of cameras to ideally your camera phone, for example. We are not there yet for such a result. Same for room reconstruction. The example I provided before in the VR section uses a lot of AI for computer vision and reconstruction, room reconstruction. Another example is what I call the HRTF, the head-related transfer function. So all our bodies are different. We have different ears. It's called the penna, the form that you have here. You have different shoulders and body shapes that really influences the way you perceive sound in space. And right now, when you put ordinary headsets on, they are all calibrated towards a standard, quote unquote, standard person HRTF. But we are all different. And therefore, if we could personalize this HRTF, you would have so much better sound and especially spatial audio. So nowadays, to do a good HRTF capture, you need to sit for probably an hour. You need to be still, and you need to use this machine. And this arc is rotating around you, sending signals and and receiving signals back. Wouldn't it be nice to replace this with a few minutes rather than hours, with a quick pictures of ears, head, and torso to do the same job via AI? And that's work we're doing. Just wanted to give some perspective of why we think it's important. We believe it's the next communications and computing platform. Here is the early computers. Here is arguably the real first smartphone with a real browser, and here are glasses that would be available in the future. And for that, you need so much power increase and low and decrease in power consumption. It's very difficult to do. So there is a collection of technology challenges, and that's what I'm taking care of here is do technology partnerships, because we cannot do it alone. We have to reinvent the display technologies. We have to look at advanced audio, body tracking, a lot of AI, and that in the form factor and milliwatts that are really very, very difficult to achieve. My proposal is to make this happen together. And with that, I thank you, and I'm ready for your questions. And here is my email if you want to drop me a line. I'm at edgar@fb.com.
It's a wonderful, 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 wonderful presentation. Absolutely fascinating. I have so many questions. But before we jump into my sequence of questions, please let me just drag in a couple of guys that I know are also very interested. Yeah, all the bad guys coming back in. I think so. Let me just introduce real quick. So in the middle of this picture, down here, we have Eddie from Telefonica. And then at the bottom of this picture, down there, we have Katie. Good morning, Katie. I'm dragging you in here early. I know that you're not speaking yet, Katie. You're speaking at 6 o'clock, but I'm just dragging you in here to say hello to everyone. Up there in the corner over there on the far side, that's Edgar from Facebook who just spoke. I think he caught the tail end of what Edgar was saying. So I have so many questions, but I'm not going to start. Eddie, do you have any questions to Edgar?
Well, apart from how do I follow that, yeah. I think some of the key things you showed in terms of the capabilities are extremely fascinating, Edgar. I mean, in terms of the skills and the people you actually need, as Facebook is evolving its journey and we move to AI, how much of this is being developed now by AI creating the code, and how much of it is still being developed by humans creating the code? It's kind of.
No, I think first of all, there is a lot of hardware technology that is not doable by AI yet. So that's one thing. The other thing is that there is tremendous use of AI into like I illustrated more to scale things, to make them more affordable, to make to enable contextual AI basically as well, which that's how I see AR as the main use. Even though today it's used to do filters and have fun, and there is no contextual AI in that respect. I can see assistant technologies of all sorts being useful. So there is a large team at Facebook working on AR/VR. We work, of course, with the other large team of AI. We also work with a collection of partners. I take care of about 200 partners, honestly, from research, from startups, from large corporations, academia, because it's a very challenging and fascinating journey. So there is a big room for AI, but there is a big room for humans in that effort.
Fascinating. Matt, Ian, any thoughts that you had?
I think from my perspective, it's certainly kind of scribbling down ideas, kind of seeing what could be possible in the very, very near future, and speaking of from a numerous different environments, be it retail, engineering, the applications of what's just been shown. And I think that's the key thing for us all to consider from what we all do, is kind of how we can use that technology going forward, because it's a game changer in many respects in being able to do that and say model those what if scenarios and actually visualize what they're going to look like. We've got a few questions come in from the audience, so I just go through those. I guess this one, without giving away too many secrets, is how do you produce your depth maps with VR?
So for VR, one of the things I can say is that we have the early prototype of VR was Rift. I have here. Actually, can show and tell. And here is so the Rift was a helmet like this, but it had a wire that had to go to your PC, and you had to have. Let me see if I can show. You had to have like this type of cameras that you put on your desk to capture where you are. With Quest, which is that device, no need for PC and no need for cameras around you. You have here cameras that enable you to do inside-out tracking. And if I had time, I could show you a video how when this is put on yourself, it scans actually. It does a point cloud of all your surrounding to make sure you don't bump, for example, into the table or the window here, and it has a way to capture all your environment thanks to those cameras and do inside-out tracking. So that's one example. Yeah, that's probably what I can say. Another question?
Another question. I guess very much looking at the roadmap as well, because again, with what you're doing, it's changing the boundaries. How challenging was it to come up with that 10-year roadmap?
So the 10-year roadmap, I didn't participate to that. It's a question to ask to Mark Zuckerberg, but I think it's a macro picture. Okay, you need to get more people connected. So that's kind of obvious. You need that in the top of technology is connect people, and it's part of our what we do. AI is pervasive, not just for the products we described, but also to fight fake postings, or to fight postings that shouldn't be posted. So we catch, for example, there is a lot of like, why is Facebook not doing anything? We do a lot. We catch more than 95% of the wrong post before anybody can. So that there is a lot of AI there. Even for humans, sometimes it's very difficult to see if something should be put on or off. But to do this at scale, because we have so many billions of people posting, there needs to be extensive use of AI. And then for AR VR, I think it's the intuition that this will be a very important platform in the future. So there you go for the main 3 families of technologies. In terms of product, what was shown on the slide are products that exist already. What was not shown is, for example, the dating app or the commercial shopping. So not everything is shown in this 10-year roadmap.
Of course not. And I think if you look at the Spark AR platform, it runs on Android, and you can get the platform on iOS as well. And I can see that being deployed on inspecting a manufacturing site. I love the way that you end up with consumer technology being suddenly used also for very industrial applications. And there's no reason not to. I spoke to a friend of mine who works in the military and in Germany, and he was saying that they are considering using a whole bunch of consumer technology applications where instead of running at the full sort of, the full temperature range and so forth for some of the silicon and so forth, they're looking at going commercial temperature range, because they can get a performance and a price point which is really applicable to what they're trying to do. So it's not siloed anymore. I really don't think so. I think Spark AI is something that's really broadly applicable.
The other thing I want to point out, I didn't mention that, but you saw I show the applications of VR in games and sharing content, but there is a huge use of it for training. Because when you are immersed, you learn by doing much more than just looking at a video. So that's one thing. Here is some hand controllers for the Quest, so that you can move in 6 degrees of freedom. This has been replaced by just my hands now. Yeah. So just the hands, you can do that. And Walmart bought a lot of our helmets so that people are trained on the Crazy Friday. Of course, that's pre-COVID, but in COVID, there is a huge demand for also remote learning, and that's a big application.
Fascinating. We need to move on to Eddie here. Thank Eddie. That was beautiful. That was really something else. I love what you've just done. And Eddie, if you wouldn't mind sharing your screen, please, that would be terrific. Eddie, what a great presentation.
Sure.
And then in the background, I'm going to start moving myself and everyone else into the green room, into the back room. Cool. And Eddie, after you, it's Katie, which is wonderful. So let's see, Eddie, if you can get your screen running. That would be terrific. Thank you, Edgar.
Yeah, I shall.
And do join the Q&A after Eddie, and there's a panel at the end as well. So please do join in if you still have time. Let's see, and Katie, I'm going to move you back to the. There you go. Let's see if we. That's it. There it is. There it is. That's a beautiful thing. And in that case, Eddie, I'm going to remove myself, and you're going to be all alone. Okay, with a couple hundred people.
Thank you.
All right, thank you.
Thank you. Thank you, Peter. And again, I thought, well, how do I follow that? I think mine will be more in the sort of more pragmatic application in terms of where are we through our own AI journey in Telefonica. I will talk about the intelligent agent that we've been building, which we call Aura, Spanish. It's spelled Aura, but Spanish pronounced Aura because Spanish. It's based on a whole bunch of let's say the Microsoft LUI AI frameworks. But before we get there, I'm going to basically talk about really what's the business problem we're trying to solve, and then how are we getting there. So effectively, when I arrived, one of the key challenges I had working with our commercial business was that we were very successful, particularly in our O2 business in the UK, but with a very traditional approach to marketing, very campaign and channel driven. We had lots of channels. We had search, we had mobile, pragmatic. Ultimately, it was kind of push, and we sort of perceived best practice was to get to be omni-channel and focused on audiences, mapping customer journeys, getting to cross-channel targeting. But in reality, what we really wanted to get to is a really customer-focused first marketing, being really moving from almost from customers to our the people who we today call customers. Tomorrow we want to call members, who work with us really in terms of an end-to-end life cycle. And clearly, well, say clearly, the challenge for us as a business, as a telecoms business, is I think we have two choices. One is we can either evolve back to being where we came from 20 years ago, being a utility, or we can become something that's more than a utility because we can deliver something unique to people, because we know where you are, we know what you're doing, and we can offer you more services and more capability that link to you as a member of our family. So that's part of our journey in terms to deliver true end-to-end customer value management. And as part of that, really, we have to deliver a set of capabilities. So through 2018 and into early 2019, we built together a whole business case around what we might call omni-channel decisioning, and that's delivering true next best action, orchestration of not just of the marketing experience, but the entire customer life cycle from, say, from cradle to grave, or from discovery through to leaving our business, but doing that in a way we get true next best offer and next best action in any channel. It involves, particularly then when you actually look at it's one thing to think about in an online context, but then also as you've got multi-channel, how do you make sure that you augment the experience in the front office? So yeah, we've reopened all of our stores. We have nearly 600 in the UK. We want to have intelligent agent and AI augmented conversations to improve the customer experience in store, but not necessarily replace human beings. I don't think we're going for the Amazon experience, but actually because there is an experience that people want in a store when they're choosing simplistically a mobile phone, but then all the accessories, the kind of contract they want. So it's a kind of, as you say, a cognitive experience that brings the best of the human and AI experience. We need advanced analytics to track the journey, and we need to make it unified and personal. Now I've got a couple of slightly more complicated slides, but we're kind of trying to get to what's the before and after. So I would say telecoms hasn't been as advanced as others in terms of its journeys, but the simple brutal truth for us in the kind of telecoms business, and particularly mobile phones and the mobile phone market has been highly profitable for a long time. Now, though, we've crossed the Rubicon where simply anybody who's here, if you upgrade your phone contract, typically we give you more for less, which is not clearly a great place to be, because suddenly you're no longer in a growth industry, you're in a managed decline. So we need to be in a position where we can actually offer our customers more and offer them in a more timely fashion and join up the entire experience. So the simple path through here is if we looked at an analysis that we did of what we call managed service revenue, which some people might know as average revenue per user, or ARPU, and we also look at somebody's net promoter score, and we calculated one of our most profitable segments of our customers, about 700,000 of them, basically on average, every time they were upgrading, we were losing £1 a month in revenue. And we had to look at how do we change the customer journey from, I would say, that original more push marketing, where actually in this example, Jane, who gets the communication from us, it's highly sophisticated, but it's still manually driven. And in this experience, you might get an out of bundle charge from us in terms of a bill. And because in the old world, our channels are not necessarily connected, our service journeys are not connected to our consumer journeys, we might find that our customer Jane is now actually starting to look at having to look at in her own way to actually find support and service. And elsewhere, we're unaware of actually the problems that she's been having, which results in us at some point offering her something when actually she's a disengaged and unhappy customer. And actually then at which point she may leave us or actually goes into an Apple store rather than an O2 store to actually buy some headphones. In the new world, we're using advanced analytics and AI, and in Telefonica, we call that fourth platform an Aura. We're actually bringing together much more of a personalized experience across all the channels. If somebody does actually get, as we call it, an out-of-bundle charge, basically maybe they've been done some roaming, not maybe so likely in the current period, but when we get back to travel, we're actually in a position where we can proactively intervene with real-time analytics. If she gets a call, if she has a problem, we can use our Aura intelligent agent to actually help her online journey. We can actually use Aura, which is available on on your phone. We're still a voice-based outfit in terms of O2. So we have Aura today. I can speak to her on my phone. But equally, over time, we're bringing that to other channels. So it's not just a handset, but we're very much committed to the voice channel as opposed to the app channel. You can ask questions about your bill. We can actually inform her in terms of the conversations. We actually improve the entire customer journey experience. And that's simplistically what we're trying to do, is really get a complete end-to-end life cycle where we join all of our conversations, we join all of our channels, and at any time that somebody needs an interaction with us, we make an intervention that supports them. If it's somebody who's got a support journey, we can use the Aura intelligent agent to dramatically improve the quality of the service and reduce the number of pointless human interactions or poor human interactions, so that when actually somebody does actually speak to a human, it's a highly informed conversation. If somebody needs to buy something, or we predict somebody needs to buy something, we can make the right interventions. And all this is about, therefore, driving improved revenue and increased net promoter score. So how are we doing that? Well, I talked about it before. Then what we've done is initially 18 months or so ago, we mapped out 30 macro consumer journeys, and we've used that as the kind of effectively to design the prototype and the model office, and then actually start to build out our solution, which we are rolling out and delivering today. It's a virtuous cycle of actually integrated analytics linked to targeting, linked to how the treatments we offer the customer, linked to arbitration in terms of what we're trying to do in terms of value, offer, propensity, and underpinned by data-driven machine learning powered models. So in our old world, where we had reasonably sophisticated models, they were by channel, and there was less machine learning, less propensity model, just more sort of traditional rule-based and linear regression-based recommendations. Now we're using machine learning, using the Microsoft LUI technology to actually drive that and augment that with the intelligent agents, so natural language processing, as well as machine learning technology in terms of Aura. So the analytics will give us the orchestration. We get more trending in terms of propositions. And whilst we started with 30 macro human-based journeys, then we start to use machine learning to actually then deal with what is in practice in real world, thousands of actual real different types of journeys with the 25 million odd customers that we actually have. So humans design the macro framework, and we use them in machine learning to gradually evolve that and improve the experience. But that doesn't mean to say humans can't intervene at any time, but effectively we're moving from process-centric thinking to data and an analytical-driven reorganization of activities. So the targeting, we're pulling together traditional historical information, traditional predictive information, adding in customer value and context. And the treatment is really then comes down from marketing speak into what is the engagement we're trying to have with the customer at any particular point in time. Are we having to have a human interaction? Are we having a service journey? Are we in a commercial journey? Are we in a cross-sell journey, upsell journey? That all is arbitrated for us in a fraction of a nanosecond. So rather than a human having to work out what the right conversation to be, the AI models and the analytical models are making the recommendation to a human being to actually of what the customer needs at any particular point in time. And we can have a completely AI-powered journey, but we still favor a human interaction at a point in time in the journey, because that's the kind of organization that we aspire to be. You know, we are very much in the human beings are still very much part of this service, a part of our modus operandi and the way we want to work. But yeah, we are improving our productivity and improving our models and improving the way we drive our customer engagement. And so I've excluded time on this. So I didn't talk about a 10-year model as Edgar did, but effectively, all I can say is that the roadmap here ran from 2018 to 2021. So we are part way through this journey, and we've basically mapped out our journey in terms of AI in 3 dimensions. One around how we're reaching. So you say in the top left, which we've already achieved, is kind of actually getting the funding. Can we demonstrate that this actually works? But have we got the resources? But then actually, what are the channels that we're doing? So we're looking at connecting to a Google virtual assistant, to Facebook Messenger, to WhatsApp, to connect Aura. So it's not just on my phone as an Aura app in what we call My O2, but it connects to all the other social and online channels that we might want to interact with. Importantly, in the middle is actually things that will actually generate revenue for us. And they could start with fairly basic activities. So what we've already done is what we call tariff recommenders and device recommenders. So tariff is literally, you know, more and more people are on unlimited tariffs. You get unlimited data and unlimited minutes, but most people aren't. And actually, you want the right recommendation in terms of your use. And actually, regulators want us to basically offer customers the lowest appropriate tariff based on what their usage is and needs is. So we're automating more of that in terms of the AI models. And linking to that in terms of device recommendations, so that we can increasingly offer you, many of our customers are dyed-in-the-wool Apple, as we would say, latest and greatest customers. They always want a new iPhone. That's kind of what Apple will do. Likewise, we have a lot in Samsung, but there are clearly any other number of new phones. So we're looking at a recommender model to say, based on this experience, actually maybe this Apple customer no longer wants an Apple, and they might take the latest, I would say, a Huawei phone, but equally latest Samsung phone, because it's got more of the features they're looking for. And we actually build out a series of models, including what we call bolt-ons, so how much can we add on, acquisition, and then what's increasingly important for us is accessories and more added value services. So as you imagine in terms of our world, where revenues from just having a mobile phone contract are declining, we need to add in more services like insurance. So if your phone breaks, more accessories. So it's not just in terms of AirPods on an Apple phone, but could be that you want some more media device. If you're an Amazon customer, maybe you're going to take some more Alexa-based devices. So we're not discriminatory here. We'll basically work with all the different vendors. It's kind of a portfolio of recommender models. That's going to drive our volume up. And then also, we're clearly trying to look at our customer service and operating costs. So some of the simplest things that we've already done include obvious things like connecting our knowledge base. So as when somebody is talking to Aura on here, they can connect directly to our knowledge base as a customer service rep would, and probably get as many of their problems solved directly by talking to the phone. And at that point, if they still need support, we can get them to a human. Simple things like improving billing support, enhancing usage report, and improving your access to if we've got network problems. And it's a harsh reality that it's still not a perfect network that any of the operators operate. So we still have downtime, and how do you actually get access to all the relevant information to support you? So we have a whole customer service journey leading to our vision of a truly cognitive contact center experience, which is still a series of human being type interactions, but very highly augmented by Aura and our intelligent agent. So we improve the natural language processing. So a human being talking to that initially wouldn't know that they're necessarily talking to an agent, an intelligent agent. Over time, we'll make it clear, though, that when they do flick from an AI to a human. But our goal here is to then dramatically transform our contact center experience. And today, 20% of our operators are O2 employees in the UK. Remainder come from a variety of partners. So probably in our instant vision, we'll still have the 20% who are employees, but we will have deflected and reduced dramatically the requirement that we have for third-party contact center support. So we are effectively 18 months, 2 years through this rollout of our experience, and it's a very interesting journey. I think so far, using the Microsoft technology, we are finding that's relatively straightforward. It's not we can get skills in the market to actually, without actually having to play completely through the nose in terms of capability. We've got a lot of reuse. We're sharing models and capabilities with other parts of the Telefonica group. And increasingly, we're trying to improve our natural language processing, which I think that's probably everybody knows who's been on this conference. NLP has improved dramatically. And that will allow us ultimately to dramatically, simplify our organization. I think those of you who were on earlier may have heard from my relative Michael Short of the same name talking about a fluid enterprise. I think for us, we don't in Telefonica use that term, but we actually are very focused on delivering a much more streamlined organization, a simpler organization driven on value to our customers as well as value to our employees. And this model will still be an employee-centric model, still a cognitive, but significantly streamlined, so we are much more productive in terms of the way we operate. Having seen Edgar, I'm not going to try and do a demonstration because it's I think I'm not going to get the same kind of acuity in terms of visuals that Edgar had, but I would encourage you, anybody who is an O2 customer or to visit My O2, and you can actually get the an hour experience. We already have a number of the recommenders already, so the devices, tariffs, accessories, omni-channel experience, and what we've seen is a 100% improvement already in conversion in the time to checkout, and improved net NPS by 20%, 20 points when we're using AI to deliver our sales. And for us, it's been fantastic because as an omni-channel business through the COVID crisis, we did have our retail operation down, obviously, for like everybody, for 3 months. Usage of Aura increased 700% during Q2 2020, and that's cost us a negligible amount of money to actually ramp up that usage. It's dramatically improved the experience that we've been able to deliver. So our NPS as a business has basically hardly been impacted over in that quarter of experience, when actually we've only had at one point we only had 10% of our call center capability online. Now we're basically closer back to normal, but the hour usage is actually maintaining at the same level and continuing to increase, and not just on the app that we've got, but on the other channels, which is a great vote of confidence for us. And conscious of time, but I'll leave you with, we have a whole roadmap of models that we're building, and this is just a snapshot of those. We're probably, as I said, we've got 40 new AI models that we're delivering this year, which we're rolling out both in the, I call it legacy channels, but also then in the AI world. And we're getting, as I said, some fantastic experience in terms of being on, and I call it a living journey. This thing will run and run, but we're getting some really substantial benefits, and we don't see any end to the value that we can deliver over the foreseeable future. So thank you, and open to any questions.
It's an amazing presentation, and I think if you just look at the sort of a couple of data bytes there. First of all, 40 AI models. I mean, that's awesome, Eddie. Surely you must agree that that's actually, considering where you were 10 years ago, you've done something incredible there.
Yeah. Yeah, no, we're really, really happy with the progress. And I think I've been, for myself, I've been on this journey over the last 10 years first with KPMG and then with Aon, and things have just so dramatically improved. Things like NLP, which was really difficult some years ago, is now more out of the box. So some of the skills become more out of the box, but and we're able to deliver value much more quickly and much more reliably, which is great. I mean, the power of the technology has been transformative over the last few years.
Another thing I was thinking about was you were saying there that you are shifting the whole business from being a process-driven business to being a data analytical organized company. That is from a corporate environment. That must be an incredible change for you to be going through.
It is. I think it's still. I wouldn't say that this is not. There's still a lot of people to be brought along the journey, and a lot of people still think in terms of function and process, and we are having to continually demonstrate the evolution. It's just changing people's thinking is as much part of the journey, and I think that is why I said it towards the end. The people point about this is fundamentally important. The technology is phenomenal, but you have to bring people on the journey. You have to look at the organizational implications, and as I said, process is something which you can document over time, but you have to bring the people with you, because without them, we are still a people-centric enterprise, and that's fundamentally important.
So Philip, we were talking about the human side about this earlier as well, and you in healthcare, I think you've gone through the same revolution over the last few years of going from being process-driven to being data analytical, organized. It's you recognize. I'm sure you recognize so much of the revolution that Eddie is implementing. We are not hearing you, Philip. Maybe you didn't hear us either. Okay. We cannot hear you. Okay. Philip, are you there? No, clearly not. Okay, no problem. But Henry, I mean, we've been talking about good red tape, and we've been talking about bad red tape, and we've been talking about how to sort of evolve from a testing perspective and so forth, and all of these things. I just feel that they come together. It's the type of organizational change that Eddie is implementing. It relates to the underlying technologies, underpinning technologies that you're delivering in order to enable that to happen. And so they go hand in hand to me. Am I mistaken in saying that?
Yeah, thinking about the formal verification and the kind of good red tape that I think you're referring to is something that you want to handle with technology as fast as possible, as you can, and kind of optimize that the kind of safety standardized testing or that kind of stuff away from your daily affairs, so you don't have to spend too much brain power on that, and automate it as much as possible. But that's pretty much the same with every single process, that you do not want to be the core competence of your company or something like that. It's something that is required by somebody else. But there's also a thin line in there, and I think the EU is kind of failing on that compared to the US, that we have quite tight safety regulations. And for example, typically in innovation, we talked in the morning session about regulation. Typically, regulation always drags behind. And in the US, there's a lot more of this culture that go ahead and break the regulations and do what you want to evolve the kind of stuff. But in Europe, for example, with autonomous cars, there's the limitation of, I don't even remember how many million kilometers you have to have of testing per software version to bring it on the streets. And I think in the US, it's like 10K. So kind of where does the limit of red tape compared to progress go?
I think another point, Eddie, and thank you for that. You mentioned NLP and how it's getting much better. And you mentioned also sometimes people want to speak to people. So I think for me, with an automated process, if things are going well, that's great. But if you have a hassle or a problem, you want to revert to talk to a person. Are you using any kind of sort of semantic or emotional analysis, or is that a future step? Or how do you escalate from maybe a virtual assistant to a real person?
That's a really good question, and I think we still have some way to go to that, but yeah, we are cognitive model. For us, it's a human augmented model, and we try to make it clear to people when can you break to speak to an agent, and actually that's one of the questions you can always ask our areas about. I want to speak to a human being. We're not queuing it yet so that you could automatically be redirected, but that's something that we want to do, because it's I think helping people with the journey is critical in this space. And we still have an awful lot of people in this country, at least, who do want to speak to a human at some point, if sooner rather than later.
It's fascinating. We've just hit 6 o'clock. So it's 10 o'clock back home in San Francisco, Katie. So Eddie, absolutely amazing. And as I said, for me, the amount that you guys have done over the last couple of years, and I think you've done something absolutely extraordinary. I'm so impressed, the whole team's so impressed by what you guys have done. Really smooth, really nice. And you deploy all over the world. I mean, it's South America, it's Spain, it's the UK. It's not easy, not easy. It's a really wonderful. Thank you, Eddie.
Thank you.
Katie, it's time for us to see if we can get your presentation running. If you can try to share your screen, please.
Great.
And in the meantime, I'll be rude and remove our fellow speakers and put them into the green room. Edgar, thank you. And I hope you take part in the panel session in a little while after Katie's talk as well.
Now, can you see this here?
Absolutely, we can see it absolutely perfectly. Thank you. And I shall remove myself here as well so that you get free hand. Thank you, Katie.
Well, thank you, Peter, and I'm excited to be with everyone today. So thanks for having me. I'm Katie Haynes. I'm the managing director of Nightingale, which is a new nonprofit seeking to advance breakthroughs in medical science by making clinical data open and available to the machine learning research community. So we're about 8 months old, and this is a collaboration between the University of Chicago, where our organization is currently housed, and UC Berkeley. So I should preface this by saying that I actually don't have a background in medicine. I have more of a tech background. I spent some time at Twitter and at YouTube, and a background in policy, spent some time in the Obama administration. But when I met with our founders about 8 months ago, Sendel Mullanathane, who's a researcher at the University of Chicago, and Ziad Obermeyer, who is a physician and researcher at UC Berkeley, I was so excited by their vision, and I really understood the urgency of the problem that they laid out, and was really motivated to join them to try to do this. So today I'll tell you just a bit about who we are and what we're trying to do, and walk you through 3 data sets and projects we have going currently that are examples of the cool things you can do with the kinds of data we're after, and talk about where we're going from there. So the best way to think about our team and what we're doing is we really want to be basically ImageNet for medicine. We believe the future of medicine is computational, and big data is going to change medicine. And if you think about all of the gains that were made in object recognition once image data was available through ImageNet, we really think medicine should follow that example. But there's a big glaring problem in this space, which is that there's little to no data. There's a few big public data sets out there, but really so much of the medical data that could make a huge difference in patient care is just inaccessible to machine learning researchers. So this really dramatically limits the ability of the papers that can be produced with insights from this data, and models and tools that can be built and actually implemented to improve patient care. And we've done a lot of market research with researchers in the space, and we know that there's a growing interest in working on hard real-world impact clinical problems from computer science researchers, and the data is just not there to meet that interest. So this is really our goal, is to unlock the data and make it a public utility and available for this critical academic research. So this tweet is kind of just a cool example of how this is still very much in the public discourse right now. Benjamin Mazer is a pathologist, and here he's talking about how clinical data, in this case tissue, is really power in medical science, and whoever has the most of it can do the most with it. And he has a cool paper called Protecting the Pathology Commons in the Digital Era, where he basically argues for what we are trying to do, that this data should be a public good, it should be open and accessible to researchers, that the data and the tools that the models and the tools that are built with the data should be open and accessible as well. So I want to underscore a couple of things. So as I said, we are a nonprofit. We are completely philanthropically funded. Our main anchor funder is Schmidt Futures, Eric Schmidt's philanthropic endeavor. And so there are really kind of two pieces to what we're trying to do. We're really trying to seed the field of computational medicine by bridging the gap that exists today between clinicians and computer science researchers. So bringing together health systems and leading clinicians with some of the best machine learning researchers in the world. And then we're specifically really interested in large imaging data sets linked to real world outcomes. So data sets like CT scans, X-rays, ECGs, linked to hard patient outcomes such as mortality or results of prior testing, or just a couple of examples. So I'm about to walk you through 3 different examples of projects that we're currently working on with 3 of our health system partners that we've entered into partnerships with. So importantly, with this, we work directly with health systems to build up and curate data sets that are clinically compelling and compelling from a machine learning perspective as well. We're focused on pointing researchers in the right direction to find new patterns and signals of disease. So basically trying to see, can the algorithm see something that a human doctor might have missed or not be able to see? And our process is, we partner with these health systems, work really closely with them hand in hand to build up a rich internal data set that is left within their system. Once that data set is complete, we take a de-identified subset of that data to then make available on our platform. So the first example I'll walk you through is pretty applicable to today. Everyone will be familiar with the resource constraints that hospitals all across the country are facing because of the strain on the ICUs with coronavirus. This is a recent New York Times article talking about the overwhelm of hospitals in Houston. And this doctor from Brooklyn who's quoted here is basically saying that because there is no way for them to predict which patients coming into the ER with COVID or symptoms of COVID will likely deteriorate and need an ICU bed versus patients coming into the ER who, might have symptoms and be sick, but will ultimately be fine. They basically admit and monitor everyone, which is a huge strain on the system. So One of our biggest projects is actually around this issue and trying to tackle this problem. We are working with a health system that's one of the biggest health systems in the Northwest. They have 51 hospitals in 7 states and health systems all up and down the Western seaboard. So we are working with them on almost 4 million chest x-rays from ER visits from their different health systems, linking those to indicators of pulmonary deterioration that are common in COVID-19. So those could be things like a radiologist notes indicating that the patient has acute respiratory distress, the need for ventilation, and actually outcomes such as death. And so our question here is, can we curate a data set such that you could produce a model that could predict pulmonary collapse in the ICU in order to manage patient care and resources more effectively? If you knew that someone was likely to deteriorate, you could keep them in the ICU versus knowing that someone, if you sent them home, was likely to recover better there, not need to come back into the hospital or suffer more issues at home. And I think it's important to point out that this is applicable to the current pandemic that we're in, but making these data available and actually producing a model around this would be useful for future respiratory illnesses because of the chest x-ray component that will probably inevitably emerge on the heels of COVID-19. The second area that we're tackling is improved cancer testing and treatment. So, this kind of hinges on the problem that we're kind of missing something with cancer. So we're doing more biopsies and we're finding more tumors, but generally, especially with late stage cancer, we fail to avert more deaths. So, there's something that we're not seeing, and we are working with a health system partner of ours to tackle this specifically related to breast cancer. So we're digitizing and linking biopsy slides to a lot of different hard patient outcomes, some of which you see here, cancer registry outcomes, slide specimen results, was cancer present or was it not, state social security outcomes like mortality. And so, from this data set, we hope that researchers will be able to produce models that are able to see new things in tumors, new patterns or signal of disease that can help create insight into the overall cancer staging process a little bit more. And the third major project that we have, and this is with a partner of ours, a health system in California, is around predicting heart attack. So 300,000 people die every year from sudden cardiac death. 45% of all heart attacks are silent, which is a staggering statistic to me. This means you could have a heart attack and not know you ever had one. You wouldn't think to inform your doctor that you had any issues, and you would never be flagged to be put in this high-risk category. So with this health system, what we're doing is linking ECG waveforms, or the electronic readings of the heart, to, again, long-term outcomes. Some of these being data on risk factors like uncontrollable blood pressure, the results of prior diagnostic testing, and other outcomes that we might be able to gather. The interesting thing about this health system that I'll just say as an aside is that they're unique in that they are a smaller, more regional health system. They serve a very, they serve basically a very underserved population. And all of their data is linked at the county level. So their health system has access to data from the criminal justice data from their court system and educational outcomes from their school system as 2 examples. So we have a lot of outcomes to play with here. And so you could think of the potential for other research questions to ask and work on with this health system. The one around heart attack that we're specifically focused on is it possible to, from this data set, produce a model that could output the probability that the patient has had a prior heart attack? So importantly here, we're not focused on predicting the probability that they will have a future heart attack. We're looking at, what's the probability that they had a heart attack in the past and it was missed? Again, what can the algorithm see that maybe is hard for a human to see? And what does this tell us about new signals and patterns in relation to adverse cardiac events? And how can that actually be fed back to the clinician space to inform diagnostics and patient care? I'll just say as an example of some of the other outcomes you could play with that linked data at the county level that I talked about, is one thing we're also exploring with them is linking ultrasounds, fetal ultrasounds to long-term educational outcomes to see how we might be able to predict perinatal complications from that linked data. So I think, the more outcomes we can gather, the more you can do with the data in terms of looking at not just medical outcomes and situations, but actually looking at the socioeconomic impact of different health conditions as well. So, one of the trickiest parts about going about these partnerships is that we don't just want single sets of data. We do want these ground truths that I've been talking about, which involves gathering data and harmonizing data from many more complex and disparate sources. But we actually kind of use this complication to our advantage because many of the health systems that we're working with, in fact, I would say almost all of them, don't have quite the capacity to be able to do this themselves. And they all have the desire to build up a data science infrastructure and a capacity for research at their health systems that they do not have today. So this is why our model of working with them hand in hand to build up their capacity works really well. We do this by embedding and working directly with them. So our data science team does a lot of this. And then we also will fund them small amounts to build up this capacity. So, funding for upgrades or digitizing slides or employees to have the capacity to come work on this data with us. We have those philanthropic funds that we can grant out to these health systems in order to get this work done. And then we leave them with a rich internal data set that they can continually use to their benefit. Another challenge that we're constantly having to think through is striking a balance between fulfilling researcher needs and what they'll want to do on the platform and what they need to do, and partner privacy concerns and risk tolerance. And I think it's very obvious to everyone that healthcare data in general is a fraught space right now, so we have to navigate that really well. So basically, we facilitate this open research without direct access to data. We do that by providing researchers with a development environment where they can code their model apart from the data. Then they can submit their code to the platform for training and testing. So they can run their models over the data and get summary data, but there's still a barrier between the actual data and the researchers, which we've found goes a long way when pitching this to our healthcare partners. Another key remaining challenge we have is costs around compute. Because we feel strongly that this should be a public good and this data should be open and available, we are making the data free for researcher use up to a certain compute limit. Once the researcher hits that limit, they'll pay a certain amount. And we're exploring an earned revenue model in the future of a subscription model for the researchers, university or institutions to enter into. But because we do feel strongly that, exorbitant amounts of cost should not be a barrier to get this data, we are currently fundraising so that we are able to offset a lot of those compute costs. And then I would say, the biggest question that we get constantly is, what's in it for the health systems? Why are they incentivized to give you their data? There's risk to them. You're not paying them a ton of money for their data, so what's in it for them? And we are lucky enough to be working with health systems that, again, kind of have this need for built up data and research capacity. I think early on, we were talking to some of the 5 biggest health systems in the US who have all of these resources already. And, frankly, they were not as incentivized to work with us because they had everything that we had to offer. But I think, there's a ton of health systems in the US who have really rich data and large amounts of it, who really want to do cool things with it and get more attention on it, and have researchers work on it and basically have publications around their data. So these are all things that we can offer that we found to be a good fit. And so the road ahead, we have several partnerships right now with health systems, both in the US and abroad. All of these partnerships revolve around forming compelling clinical questions, research questions, and curating data sets like the 3 examples I walked you through. And we'll be launching our platform in spring 2021 with 2 to 3 key data sets. A big focus for us with the launch is kicking off a couple researcher challenges, inviting researchers to come work on the data sets hosted on the platform and come up with innovative models to encourage kind of competition and collaboration in this space, bring some attention to it. So I know we're coming up on time. I think I would just say thank you for inviting me to be here. We are trying to socialize what we're doing and get our ideas out there. So this is great for me. And I think any feedback you have in any of the areas listed here would be wonderful. So thank you so much.
Oh, thank you, Katie. Thank you, Katie. And I can see a whole bunch of ways in which people that we work with are going to be interested in working together with you, Katie. One of the questions that I'm sure a lot of people will be asking will be the one that you've actually already answered, which is the non-profit question. So if people give all of their data to you, then what? So you might as well just hit that one out the park,
Yeah. So I think, we're attempting to create demand in this space. I think it's very important for us to be nonprofit when we launch, to show the value of this data and that there's a huge value in having a low barrier to entry to access it. I do think, though, that, and we're kind of going to have to figure this out as we go after we launch. There's huge value, and there will be huge value in demand once folks see what's possible with this data and the breakthroughs that this data drives. So I think we will see, as a nonprofit, our costs decrease as hopefully health systems want to be involved, and want to have their data hosted on the platform. And I think that also universities will be happy to pay access to some extent for a subscription for the platform. So I think I don't see a world in which we would ever be for profit, but I think after we launch in the 3 to 5 years afterwards, we can start earning some revenue and becoming a little more not so dependent on philanthropic funds.
Fully understood. Let me add Philip to this, our mutual friend Philip, to this stream here. And I think you've met.
Yeah, we know each other well.
And I'll bring in Edgar to this as well. Let's see if I think Edgar would be interested in using some of your images inside his virtual reality and augmented reality things. It would probably cause havoc and highly inappropriate, but hey, that's only fun. Ian, please, would you mind joining us? This is the final panel here, and Matt, it would be great to have you in here as well. And Henry, if you have another few minutes, it would be great to have you on here as well. If we're lucky, we can even get Anthony to join us for another while. Let's see. Whoa, Anthony. Here we go. You still haven't headed into the Notting Hill evening.
That is yet to come.
That is yet to come. That is yet to come. I'd love to join you. Katie, you've just spoken about some really important things. I don't know who should be starting on this. Philip, you're very close in terms of medical. Do you see this? Well, how do you feel about this whole thing? Is Katie making
No, I'm so glad that Katie was able to join us and to present here, because I think that in terms of impact on healthcare, one of the themes that we've talked a lot about here today is how AI and machine learning can have an enormous impact on helping us to really transform the way we deliver healthcare. And a lot of the work that we're doing in Sweden with the various healthcare systems there, I think is really all about that. But I think what Nightingale is doing here, I can't overstate the importance, I think, of that contribution. And I think Katie outlined it so well about how there is such a lack of data available for the whole research community, because so much of it is locked up in proprietary systems that are either don't have an incentive or actually have regulatory constraints in sharing. So I think that it's an enormous challenge, but I think it's an incredible example, and one that we're working with them to try to help move forward.
I find it amazing. At the risk of repeating myself, I'll mention the word good red tape again. I think if you look at the things, Anthony, that you've been doing in the areas of privacy and so forth, and if you look at Philip, if you look at the way that you've been able to use data from Sweden in the United States and vice versa in order to achieve great results, Anthony, wouldn't you say that where there is a will, there is a way? You can simply navigate these things. It is possible to navigate them for good.
Yeah, I mean, I think, my view of certainly the general data protection regulation is that common sense should prevail. And it's also interesting, I mean, it's fully understood that there is a lot of caution when it comes to private bodies and public sector bodies sharing medical data, because it's sensitive medical data. It's the most sort of protected form of data that there is under the regulation. But there, in a sense, there is where there's a will, there's a way, and it probably should worth mentioning in this particular forum that the regulation, specifically Article 9 of the General Data Protection Regulation, makes specific provision for sharing sensitive personal data in the context of medical diagnostics, in the context of the prevention and treatment of medical conditions. Now, obviously, I can't speak to what the situation is across the pond, but in the sense, yes, there is. I think in this area there is good red tape rather than bad red tape, because what it says, if you are going to, if you can find a lawful basis for sharing the data, you need to do it in a proportionate way that protects the data and keeps it secure. and prevents misuse. So yeah, I would say that would be an example of good red tape to me.
Yeah.
You know, just
I
to,
guess
to jump,
a lot.
oh, I was just going to follow on to that. I think that, you know, there's the regulatory constraints that I think can be a barrier to using for this kind of very necessary secondary use of medical data. But I think there's also a political dimension oftentimes as well, which, you know, is another feature, I guess, of some of the hurdles that we had in our early work in Sweden. You know, many healthcare systems around the world are politically run organizations, and so there is there's that added a dimension really of needing to have the optics of this, you know, right, so that the public has a sense of trust around this, which is, you know, it's related to, but it's actually separate from, I think, the specific provisions of GDPR or HIPAA. And so I think that's also, you know, something that we have to do this in a way that the public feels confident that their data is not being misused or used for a purpose that they don't support.
Yeah.
Absolutely.
I mean, we've spoken with a company, healthcare organization recently, and they're desperate for help. And a lot of the services they need are sort of cloud services, but they will not move anything off premise. They are just mortified at the thought of even moving one bit of data. And even people off-site don't have access to on-site data. So it's kind of somehow, exactly as you've said, to build that confidence to show that we're doing good and that their information is protected. But it's a hard call.
Yeah.
That was an interesting thing that Mikko spoke about this morning, the Huawei CTO, that in terms of the engineers he has who work for him in Europe, they were not given access to any sensitive Huawei information. That was all hosted inside China, and that should all be separate and and so forth. And then COVID hit, and over a period of 24 hours back in March, wham, everything changed. And now every single one of those same engineers in Europe are able, because they have the technologies. So it is possible to do it, and they're able to perform their work. So where there's a will, there's a way. It's a mindset question, I think, and I think that Philip, what you said about the optics, it's critical, because if you get on the wrong side of the wave on that one, then you'll be paddling really hard. You're going to be gliding nicely on that one. So but Edgar, you must be super interested in using these medical images as part of AR and VR. Surely you want to project these things on people.
I'm interested personally, and Facebook is interested as well in improving health. You see, there is a lot of initiatives to even alert people and remind people to go and check-ins. There is Facebook groups on COVID and collaboration with CDC and so forth. I think there is also interest in preventing heart disease or conditions, not just with images but with sensors. And central to all this is what we just talked about, which is regulation, policies, privacy of data, and so forth. So if there is a way to anonymize all those data with the consent and regulation, that's fantastic. I've seen also colleagues of mine doing remote diagnostic of skin conditions, for example. There is all sorts of startups that are doing great doing that. So we're interested. I mean, I cannot talk about on behalf of the Zuckerberg initiative, because that's separate, but that's another area of interest to improve health. So I wouldn't reduce it to just AR, VR, and computer vision, I think there is so much to do jointly that I pinged the Cathy on the side. It's very interesting.
Katie, you were about to say something earlier. I'd love you to.
I was just going to say this is a fascinating conversation, and I would love to stay in touch with all of you because these are the exact things we're navigating and trying to think about. And Tony, just as an aside to what you were saying, I failed to mention this in my presentation, but we've actually had better luck navigating data use agreements with health systems in Europe rather than the US. Those conversations have moved more quickly and basically been less fraught than the ones here in the US. And I think it's because of the provisions in the GDPR around making research data for research available. But I think what Philip said is, and what everyone has been saying is what we ultimately have to do successfully, which is convince, and assure the public that their data is being treated well and that this is to their benefit. I think, think legislation in the US is maybe headed to make this a bit more difficult. And I think that part of the reason to position ourselves as a nonprofit and really academically focused is to, assure people of this. But I think it's definitely, it's not been easy, and I think it will continue to be challenging. So I appreciate the discussion.
Yeah, something that we were referring to earlier when we were talking about the way Finland has now constructed the laws around all the healthcare data. Have you had any touches with that? As I think that might be something that interests you with the Finnish biobanks being now there's actually biobank law in Finland which accesses all of that data for research.
Yes, amazing. I just saw your comment about that. Actually, one of our partners is in Finland, and things have progressed well for that reason.
Yeah, and also I was interested that you said about predicting the EKG heart attacks from EKG data. That's something interesting that's also been, I think, going on with Tampere Medical Imaging Group. So that could be some interesting connections to you. There's a lot of overlapping there.
Oh yeah, I would love that. If you're in a position to make an introduction, that would be wonderful.
Yep. Yeah, I used to dabble in computational systems biology back in the day.
Oh, cool. Very cool.
Katie Henry is connected there.
Perfect.
I assure you. So that's cool. Ian, you be quiet for a moment. And Matt, you've been very shy for a moment.
No, I was just wondering about, you talked about people with previous conditions, Katie, and how you can somehow work that out. How much of a window is actually valuable to you? So how far can you go back, or is there a limited time frame?
Oh, yeah, that's a great question. We try to go as far back as possible with everything as we can. This was a learning curve for me as I ramped up, but the basic way our data science and research team work is try to get as much data as we can up front and then kind of sort out like what's the most valuable from there. But just because, it's sometimes pretty lengthy to get access to these systems, and we want to make as streamlined as requests as possible. So we go as far back as we can, get as much as we can, and then work from there.
Fascinating. Cool. Thank you. All right. So I think we're pretty much coming towards the close of the day here. Philip, anything you'd like to add about this? Any further thoughts that you have?
Well, I would again, point to the the impact I think that this can have. And when we were talking earlier about this vision for what healthcare could look like in the future, and the ways in which demand for acute care services could really be significantly impacted when we are able to develop at scale predictive algorithms based on AI and machine learning that can diagnose disease or the risk for acute diseases that today we tend to treat with very resource intensive hospitalizations. If we can do and sort of realize the vision of being able to have multiple different algorithms for predicting the risk of heart attacks and strokes and other conditions that account for a really significant part of the burden of disease and the utilization of resources in the healthcare system. Resources can then, well, first of all, I mean, the benefit to patients is enormous, right? I mean, being able to prevent these kinds of conditions that shorten life, but also create disability and hardship at an enormous scale. But also that it frees up resources in healthcare that we can then invest in other things, in creating access to other populations that are underserved, or to be able to take advantage of new diagnostics and treatment. This is really the vision that I think many of us have for what how healthcare could be really transformed. And I think the key to doing that is being able to promote research in this area. And I think that's why I feel like Nightingale is really a part of the realizing this future vision. So I'm a big fan.
I'm a big fan. I'm a big fan too, and I think it's a key element, because if we take the whole thing, if we take the things that Edgar was talking about in terms of implementing the things using, I mentioned earlier, Spark AR, Edgar did technology. Those types, when you start implementing those types of technologies on the type of handsets that Mika was talking about this morning, then suddenly you have something which is cheap and affordable, and you're running things on something cheap and affordable using consumer electronics, which is really powerful. And if you then take that in and think about the type of care journey that Philippe, you've spoken about, where you're saying that, okay, right, so we're here now, we're now in the world of predictive medicine, and we will be in the future in the world of prescriptive medicine, where we will be. So that's the journey that we're going along, and we need to do that in a manner where we keep Anthony on our side, so that we're not taking liability risks and so forth. But we do need to go from informative to predictive to prescriptive over the next 10 years. We must, for financial reasons, we must. So that means that if you want the level of precision required, then you have to look at the individual interactions where you're in touch with one of these patients. And you have to look really hard at that touch point with that patient, which kind of links into the things that Eddie Short was talking about from Telefonica in terms of their CRM interactions. So that individual interaction has to be so valuable and so precise. And at that point in time, you need to get as close as possible to the correct initial diagnosis, so that you're guiding it the right way. And otherwise you're wasting everything. You're wasting the opportunity to fix it quickly, ultimately. And so these things come together. And Katie, I really feel that the things that you're working on, they are a key element in those things. So I'm totally excited by it. It's and all of these elements come together. They it's all part of the same thing.
Yeah, I think the oh, go ahead, Katie. I'm sorry.
Oh no, I was just going to say I completely agree, and that's why I really hope that this kind of network of folks can keep in touch beyond today.
Yeah, I was just going to add on. I mean, I think Peter, what you're sketching out, I think, is the logical sort of follow-on to what we're talking about. Because when really, I think what we see is this this trend towards shifting care delivery in the future from a hospital-based point where a majority of healthcare is delivered to one in which, you know, the only people who are really getting admitted to the hospital in the future are to have procedures that, you know, can only be done in hospital, and then being admitted to the intensive care unit, basically. And that the vast majority of other kinds of hospitalizations and monitoring and testing and so on, that can happen somewhere else. That can happen in the home, and you know, and I think you talked about the way in which, you know, personal electronic devices are going to evolve, you know, in the way that, you know, phones and watches and now are doing monitoring. I think that trend is only going to continue, and there's enormous opportunity there. You know, both in the commercial side, but also, you know, just in terms of, you know, in terms of the healthcare system of reducing cost and allowing care to be, you know, more personalized and more individualized. And I think these are super exciting trends.
They are. And Henry, I think the work that you've done in the space is also highly relevant there, because if you're going to start doing those things, if you're going to predict and prescribe in the area of medical, then everything that helps you predict the quality of that situation is kind of critical.
Yeah, even going into the model testing and AI testing field, that's then a totally different beast on how to validate biases and all the other stuff. And really going into this like non-deterministic testing field is something that's of interest of mine, and it's a difficult challenge to do, as then you have to really know what should be the outputs. But typically, you don't know all the cases of the output, so there's to be kind of like statistical testing, and it changes also the way that testing is typically done nowadays. That it's just test case, pass, fail.
Before I leave,
sure, but sorry.
Before I leave, I'd like to contribute one thought. It's all very, very relevant to predict and cure with AI. But let me tell you a personal story. I have sleep apnea, and I went to a sleep clinic, and they put tons of things on me, and I didn't care, and I didn't cure it, and I had a CPAP machine but never used it. And then after a while, I noticed I have a tachycardia. Why do I know that? Because of the Apple Watch. And a lot of studies have been made, and they didn't find anything wrong with my heart. And then I thought, well, maybe it's sleep apnea. So I put a ring that monitors during my sleep the heart rate and the SpO2, and then I noticed it's serious. So I convinced myself only with that, not with the sleep study. And now that I do this CPAP, my heart rate is normal. So there is this as well. It can educate the patients and also the doctors, because nobody said, "Oh yeah, you have tachycardia because of sleep apnea." I had to do this myself. So with this, I unfortunately I need to go. It was really great meeting you, and let's keep in touch.
It's wonderful, Edgar, to meet you. I had no idea you had apnea. It's a dreadful condition. I hope you're getting through it.
Yeah. I think many people don't know they have that, and it is a big issue. And of course, you can cure this by losing weight, which is tough, and then changing so much things in your face, jaw, and so on, that it's not advisable. So I can show you there is a very big difference between the nights I put it and the nights I don't. So it's very, very serious. Yeah.
But this is we have to take the facts seriously. We came into the early days of February, and I spoke to my daughter Alice, and I said, okay, so this COVID thing is happening big time, and and I'm in the risk zone. I'm a smoker. I'm old, and I'm a male.
You can do one thing about this. You can stop smoking, but the rest is.
And my daughter said, okay, fine. So you're old, you're a smoker, and you're a male. So very simple. Keep it reasonable. Change one of those three. I chose to change the smoking.
sorry.
So I quit smoking that day. That day we had that discussion. It was a Saturday. I quit smoking that day.
Thank you.
All right. Thank you, everyone. On that note, thank you, everyone. Shall we keep in touch and let's do this again?
Yes, please. Thank you so much, everyone.
Thanks, everybody.
Thank you.
Great to talk to you. Look forward to being in touch. Bye-bye.
Great.
Bye.
Bye, everyone.
Thank you. Thanks.